Hey people, and welcome to this video. In this video, we are going to be working on the grade 12 mathematics paper 1 for November 2024. This paper is worth 150 marks and the time allocated is 3 hours. Remember the instructions, just remember to round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this video. Question 1.1.1, we are told to solve for x if x multiplied by x minus 3 is equal to 0. So the idea behind this is we have something, some number, multiplied by another number, and it gives us 0. Well, the only way this is possible is if the first number is equal to 0, and then you said 0 times the other number, and then it gave you 0, or if you have the case where the first number multiplied by the second number and the second number happened to be 0, and then that gave you 0. Okay, so to solve for this question, we simply say that it's either that x is equal to 0 or x minus 3 is equal to 0. Therefore here, if we solve for x is equal to 3, and those are our solutions. Question 1.1.2, we are given a quadratic equation and we are told to solve for x correct to 2 decimal places. Now, we know this is quadratic because you can see that the highest exponent on x is a 2. And with that being said, this is not in the standard format of a quadratic equation. So the standard format of a quadratic equation is ax squared plus bx plus c is equal to 0. And so from that, you can see that one-hand side of this equation is not equal to 0. So we're going to have to take the 4x over to make sure that this is in its standard form. So we're going to have 2x squared and then minus 4x plus 1 is equal to 0. Okay, great. So now that it is in its standard form, we know that we have to correct to 2 decimal places, meaning our solutions are going to be irrational. Okay, so that means that we need to use the quadratic formula, which looks like this. And now that we have the quadratic formula, we can just substitute our values of a, b, and c. So from our equation, we can see now that a is 2, b is negative 4, and c is positive 1. So let's go ahead and substitute that in place of a, b, and c. So now that we have substituted, we can find the values of x. Okay, so x is finally equal to, and starting with the negative, okay, we have this, which needs to be in decimals. So that is going to be 0 point, and you're rounding off to 2 decimal places. You see, after the second decimal place, we have 2, so this rounds down. So this is 29. And you can just go ahead and change that negative to a positive, and now we have 1.7, and that is going to round up, adding a 1 to the 0. And those are our solutions. Question 1.1.3, we are asked to solve for x given this quadratic inequality. Okay, because we have a quadratic expression on this hand side, we have to factorize this. So to factorize this expression, we're going to go ahead and open up 2 brackets, and it is still greater than 0. And then ask ourselves, what multiplied by what gives you x squared? And that would be x multiplied by x. And then what multiplied by what gives you a negative 3? And that would be, well, the factors of 3 would be 3 and 1. But you know that it should give you a negative 3, so 1 should be negative and 1 should be positive. So to decide which factor should be negative, you can focus on the coefficient of your middle term, which should be negative so that this remains negative. So we can give the negative to the bigger factor. So if you make that minus 3 and positive 1, you know that negative 3 plus 1 really does give you negative 2. Okay, so now that we have factorized this, we can move on to solving for x. Since we have an inequality, we're going to set down our critical values. So our critical values are really just those points that mark where our solutions start. And they really just work like solving for x. So if you're solving for x in this equation, x minus 3 equals 0, then your critical value would be x is equal to 3. Then if you were solving for x in this equation that is set equal to 0, then x would be equal to -1. And now that we have our critical values, we can go ahead and draw our parabola. So from the equation that we have, you can see that the coefficient of x squared, a, is equal to 1. And if it's equal to 1, it means that a is greater than 0, meaning we are going to have a concave up parabola. And then we can also just include our x-axis. So we'll put our critical values down. Remember, they are points where the y value is equal to 0. If you had to make that equation equal to 0, that's where you get your critical values. So it means that x here would be -1 and x here would be 3. Okay, so that's the smaller, that's the bigger. And now we have to answer the inequality. The inequality specifically says that this expression needs to be greater than 0, meaning when you substitute x values here, that those x values produce a result that is greater than 0. The result we get are y values. So they're really saying, where are your y values greater than 0? Okay, so we can look at this by looking at the y-axis quickly. You see that on the y-axis, you have places where the y values are specifically greater than 0 and places where they are less than 0. We need it to be greater than 0. So let's look for the places where the y values are greater than 0. If you look at these points over here, the points down here, do you see that they map to y values that are less than 0? So we know we are definitely not taking any of those. You need to take ones that are greater than 0, meaning you need to take every part of the graph that lies above the x-axis. Okay, so that will be over there and over there. And at this point, we don't need any of this anymore. So to find out where exactly these x values are, we can line them down to the x-axis. So we're lining them down to the x-axis so we can find out where they are relative to these critical values. Do you see that these are values that lie to the left of -1? So they're moving towards that direction. And so what that means for -1 is that our solutions lie where x is less than -1. Okay, so do you see that the direction helps you with the inequality? And on this side, you can see that these, if we line them down to the x-axis, they're moving towards the right-hand side, okay, of 3. So this would mean, so we can tell them, or x is greater than 3. Again, the direction helps you with the inequality. And those would be our solutions. Of course, you could also write these in interval notation. So if you wrote it in interval notation, it would look like this. We're basically saying that the x values, okay, if you look at it on the number line, you will better be able to understand it. When writing in interval notation, we say x is an element of, and then you're always going to read your intervals from the left-hand side to the right-hand side because it's all through here. So you can see where they start would be at -infinity. So we say that it's going from -infinity and then it ends at -1. Not exactly at -1 because remember this says just greater than 0, not greater or equal to 0. So we'll close that bracket there and then we can say or you could also just say union, which is really just the symbol for or. We know this from probability and then we can go ahead and write that as well. So x is greater than 3, it starts at 3 and then it heads towards positive infinity. So it starts not exactly at 3, but just after 3 because it's not equal to 3. And then it ends at positive infinity. And those would be our solutions. You can either write it like that or like that. Question 1.1.4, we are given an exponential equation and we have to solve for x. So we know it is exponential because the x's are in the exponents. So in this exponential equation, one thing you're going to notice is that there is a repetition of a specific term, which is really 2 to the power of x. We have 2 to the power of x here. Of course, it's 2 to the power of 2x. But if you wrote it as 2 to the power of x and then raised to the power of 2, then it still means the same thing since you would have to multiply the exponents. So we could also rewrite that so that we can clearly see the 2 to the power of x being repeated. So that's minus and we have 2 to the power of x. Then we have a plus 2 in the exponent. So what that means is you must have multiplied by something that was written with its base being 2 and then you had an exponent of 2. Since when the bases are exactly the same and we are multiplying, you end up adding the exponents. And then, of course, we have the minus 32 is equal to 0. Okay, so this is our equation. And now we are going to use a method that makes this simpler to solve for. And that is called the K method. So with the K method, it really just says you need to let K be equal to whatever was repeated, which was the 2 to the power of x, which we can see repeating there. So we say let K be equal to 2 to the power of x. So this means that our equation is now that would be replaced with K, so K squared minus, and then that would be replaced with K. But you can see that this is 2 to the power of 2. So let's just rewrite it as a single number. Now 2 squared is 4. And then we have 2 to the power of x, which we replace with k. And then minus 32 is equal to 0. Okay, great. We have something that looks more familiar. This is a quadratic equation where we have to solve for k. So we can open up two brackets, set it equal to 0. And then we have what times what gives you k squared, which is k times k. And what times what would give you 32, specifically negative 32. Well, with this, you're going to have to choose factors that are really just close together. They're not really that far apart. So something like 2 and 16 is definitely not going to work because 16 is way too big. So let's try 4 and 8. Okay, so now we know one of it needs to be negative since 32 is negative. Which should be negative so that the middle remains negative? The 8, the bigger factor. So if this is positive 4 and negative 8, we know positive 4 minus 8 is equal to negative 4. Okay, so let's solve for k. This therefore means that k is equal to negative 4 or k is equal to positive 8. But remember, the question is to solve for x, not k, so we're not done. We need to solve for x, meaning we can go back to what k was, what we replaced with k, and that was 2 to the power of x. K was 2 to the power of x. So this means that 2 to the power of x is equal to negative 4, or 2 to the power of x is equal to 8. Okay, let's talk about the first one. We have 2 to the power of x equals negative 4. Is that possible? Can you take 2 and raise it to an exponent and then it gives you a number less than 0? If you try different numbers, if you try negative 1, you will notice that will give you a half. Try negative 2, it's going to give you a quarter. If you try positive numbers like 2, that's going to give you 4. So do you see that this will never be possible? It is not possible to raise a base of 2 to any number and get a negative solution. So this cannot happen, and we'll just say that 2 to the power of x therefore can never be equal to negative 4. And now moving on to this. Okay, we have 2 to the power of x equals 8. The left-hand side needs to be equal to the right-hand side. So why don't we just rewrite 8 so that its base is 2? So that will be 2 to the power of x is equal to 2 to the power of what gives you 8? It will be 2 to the power of 3. And now do you see that only if x is equal to 3, your left-hand side will look perfectly like your right-hand side. And so therefore, x is equal to 3 only. And that is the answer to that question. Question 1.1.5, we are given an equation and you can see that there is a surd in this equation and we need to solve for x. Okay, so straight away we can see the major problem here would be this surd. We need to get rid of it. So the best way to get rid of this surd is to isolate it. Leave it on its own on one side and take whatever is not in the surd over. So negative x is going to go over. So when we rewrite this, this is the square root of negative 2x plus 4 is equal to, and I know there's a 2 here, but this becomes positive. So we might as well just write it before the 2. So that 2 was also positive, so it stays positive 2. Okay, so now that we have this, we can get rid of this square root. And the way we can get rid of a square root is by squaring it. So we will square that. But this is an equation, and what you do on this side, you have to do on the right-hand side as well. So this means that they break open because they're the inverse of each other really. And we have negative 2x plus 4 is equal to, and then we have this. Now you have the choice to either simplify this by saying x plus 2 times x plus 2, which I think takes a while. So I'm going to deal with this using a simple method. During your exam, you want to make sure that you save as much time as you can. Using this method, we first square the first term, which is x squared, and then square the last term, which will give you positive 4. Then say the first term multiplied by the second term, which will give you 2x, and then this needs to double. So you multiply it by 2. And so that gives you a positive 4x. Okay, this looks good now, and we just need to solve for x. So to solve for x, bring all the like terms together. So we're taking all of that over. So this means we'll have nothing over here. 0 is equal to x squared and then plus 4x. And when you take this over, it becomes a positive 2x. Those added together give you positive 6x. And then we have positive 4, and you can see that they're exactly the same. They would have already cancelled on both hand sides because we have positive 4 and that comes over and becomes a negative. Okay, so this is really all we have, and we have to solve for x. You have a binomial, 2 terms. To solve for x here, you can factorize, but we can't use trinomial factorization because there are only 2 terms. So what type of factorization can you use here? You can use highest common factor. So let's take out the highest common factor from the first and second term. That would be exactly x. And taking that out, what are you left with in the first term if x is your factor? X times what gives you x squared? X times x. And then in the second term, x times what gives you positive 6x? That would be positive 6. Now that we have this, we have something multiplied by another thing give you 0. The only way that's possible is if the first number is equal to 0 or the second value is equal to 0 as well. So here, if you solve x, x will simply be equal to negative 6. So our solutions are x is equal to 0 or x equals negative 6. But slow down. We still have to find out whether this is actually true or not. Because do you see that this is an equation with surds? And what we did here was we squared both hand sides. That tends to tamper with the solution. So you need to check whether your solutions are actually valid. So to do this, it is quite simple, and you can even use a calculator to do this. You are simply trying to ensure that the left-hand side really is equal to the right-hand side. So when x is equal to 0, we will substitute in place of x, we'll substitute 0 and find out if our left-hand side really is equal to 2. And you see that when we substitute 0, that we get an answer of 2, meaning the left-hand side really is equal to the right-hand side for x equals 0. Now let's try that with negative 6. If you substitute negative 6 in place of 0, what do we get? So that's minus and of course minus 6, which gives you 10. That is not true. That solution gives us 10 instead of 2. So we are going to cancel that solution, and x is therefore equal to 0 only. And that is the solution to this question. Question 1.2 asks us to solve for x and y simultaneously. Okay, so with these, we can look at these 2 equations and choose the equation where something, a variable, can be made easily a subject. So from this, do you see that in this linear equation, you have y on its own? So we can easily make y the subject here. So we can call this our equation 1, and then that will be by default equation 2. So now we can form equation 3 using equation 1. You can leave y on the left-hand side, and we have y is equal to, and you still have 3 on the right, and then take your 2x over. And this is now our equation 3. Okay, now to solve for x, we can go ahead and substitute equation 3 into equation 2. So wherever you see y, substitute it with 3 minus 2x. So we have y squared. So in place of that squared, we're going to say 3 minus 2x. And then we have plus x and then multiply by 1. So we'll replace it with 3 minus 2x. And then this is equal to 2. Okay, so let's go ahead and simplify. Simplifying this, we square the 3 and that gives you 9. Square the negative 2x and that gives you positive 4x squared. Then first term times second term, which gives you negative 6x. And then you double that, multiply by 2, which gives you negative 12x. Then we have these, which we can distribute, and that's going to be positive 3x and negative 2x squared. Now we can just go ahead and take this over, so it's minus 2 is equal to 0. Okay, now we can put our like terms together. So in the order of its exponents, those two go together and become 2x squared. These two go together and they become negative 9x. And then lastly, the constant. So 9 minus 2 gives you positive 7 is equal to 0. Okay, now that we have this, let's go ahead and factorize. So we can use the factor method here. So we'll multiply the coefficients of the first term and the constant. And that would give us 14. Now, this 14, we are going to use this and find the factors of 14. That would give us the coefficient of the middle term. So it works a lot like factorizing simple quadratic equations. So what are two numbers that we multiply that can give us 14, but when added together, they give you a negative 9? That would be 7 and 2. Okay, but do you see that this is negative? So the only way that that could stay negative when added together, but at the same time stay negative when you multiply them together, is if they were both negative. So negative 7 times negative 2 is positive 14, but negative 7 minus 2 is negative 9. Okay, so this is how we're going to rewrite this here. It is 2x squared, and then we are going to rewrite these in terms of x, because you see that they add up to negative 9. So we are rewriting negative 9 as negative 7 minus 2. But we're not just going to put them in any order. You're going to put the negative 2 with the 2x squared because it shares a common factor with it. But remember that we are trying to represent negative 9x, which is already in terms of x. So this is negative 2x. And then this is going to be negative 7x. And then we continue with our equation. Plus 7 is equal to 0. And now we can use grouping. So we group these two together and these two together. So take out the highest common factor between these two terms. That's going to be 2x. And then what are you left with? In the first term, you'll be left with just x. And in the second term, you'll be left with negative 1. Okay, second term. Take out a common factor. That would be negative 7. And what are you left with in the first term? That would be x. And in the second term, minus 1 is equal to 0. Okay, do you see that in this new simplified equation, all that is common between the two terms that we have, because that's what we have, two terms, would be the brackets. So we're now going to take the brackets out as a common factor. So we have x minus 1 that comes out. And then what is left in the first term after taking out that common factor? It's going to be the 2x. And in the second term, you're left with negative 7 is equal to 0. And now we can go ahead and solve for x. So here, x is equal to 1, and then here we can straight away say 2x is equal to positive 7 because we're taking the negative 7 over since they're equated to 0, and then divide both hand sides by 2, which just gives you 7 over 2. Okay, so we have solved for x, but remember the question asks you to solve for x and y. So which equation could we use to solve for y? Well, use the equation that already has y as a subject, so that would be equation 3. So you can go ahead and call this equation 4 because they are equations. They say something is equal to another thing. And so substitute equation 4 into equation 3. So equation 3 is y equals 3 minus 2x. So we'll say y equals 3 minus 2 and then substitute the x value. The first x value we have is 1 and y equals 3 minus, that's just 2 times 1. So that is 1. Or the second solution would be 3 minus 2 times 7 over 2. And then you see here that the 2 and the 2 in the numerator and denominator cancel. And you have 3 minus 7, which is negative 4. And those are our answers. X equals 1 while y is equal to 1. Or x is equal to 7 over 2 while y is equal to negative 4. Question 1.3 says, consider the product, and then we are given these and they are multiplying. Now they tell us that each factor in the product is of the form 1 plus 1 over n, for where n is greater than or equal to 2, which we can see it starts at 2 and then it increases so its value is greater than 2. Then they ask us to determine all the values of n for which the product will be an integer value. So from this, the main goal is to find the product. And you find the product by simplifying these that are multiplying together. So how about we take this and simplify it further, because right now they are in the form of whole numbers plus fractions, and we could just rewrite them as improper fractions. So to simplify this further, we can just add them together. So that would give you 3 over 2. This would give you 4 over 3. And then the last one would give us 5 over 4. And this keeps going on. Now to find out how we can multiply this, let's find out where it would end. So let's go ahead and write down a factor that would represent the last term. Regardless of whatever it is, we know that it's going to have this form. So it's going to be in the form of 1 plus 1 over n. Now, of course, we could also represent that here. Just see this as it's 1 plus 1 over n. 1 over n is a fraction. So we could rewrite 1 as a fraction as well, so they can be added together. But the denominators need to be the same. So you're really just taking 1 and you're multiplying it by n over n. And you're adding this to 1 over n. So on the numerator, you'll just have n plus 1. And on the denominator, your denominator will stay exactly the same. So n plus 1 over n is our last term. And this is what we have so far. So let's go ahead and simplify this further. Do you see that as these fractions multiply, the numerator of the current term and the denominator of the next term would cancel? Same thing would happen here. This 4 and this 4 would cancel. And this 5 and the next 5 would cancel. Okay, so it means something here would cancel. Let's go ahead and write a second last term so we can understand how this works out. As you can see, these factors are increasing by 1. So it means that if you had n plus 1 as your last term, the numerator of your last term, the previous term would just be 1 less than this. So this would be n plus 1 minus 1, which is n. And the denominator would also be 1 less than that. So it would be n minus 1. And so this is what it would look like. Now, cancelling, we can see what happens. You see how the n here would cancel with this next n in the denominator? It's the same way we would have had an n minus 1, a previous term here, cancel with the second last term, whatever that second last term is. And remember, what they're doing when they're cancelling is they're really just dividing, because had you had these together and you had to write it as a fraction, then do you see that the 4 and 4 would cancel because they're really dividing by each other and becoming 1. So if we rewrite this, all we'll have left is in the numerator, we'll have n plus 1. And in the denominator, the only thing that would not cancel would be the 2. So this is in fact the product. Now the main question is to determine all the values of n for which the product will be an integer value. So for which values of n will this remain an integer value? For this to remain an integer value, then because it's divided by 2, then you need to ensure that the number on top is also divisible by 2. In other words, we're really saying that n plus 1 needs to be even. It must be even. But the question is not specifically asking for n plus 1. It's asking for all the values of n. So it means that if n plus 1 must be even, then n specifically must be odd. That is the only way this would be even, because if you take an odd number and you add 1, it will make it even. So is it just odd for all values of n, or should we restrict it? Do you see that at first we already had it being restricted? N had to be greater than or equal to 2. So you can see from this we're not considering any negative numbers. So what does n have to be to satisfy this? We can see from the product that when n is equal to exactly 2, then this becomes 3 over 2, which is not an integer value. But when n is values that are greater than 2, then we have 4 over 2, which is 2. And also remember, n specifically has to be odd. So it's contradicting to say that n should somehow be equal to 2. So it can't be greater or equal to 2. Rather, it's just going to be greater than 2, since no negative values are considered here. So as long as n is odd, where all the n values are greater than 2, then the product will always be an integer value. And that is the answer to that question. Question 2 says 2.1, the first term of an arithmetic series is 7, The common difference of the series is 5, and the series contains 20 terms. So let's go ahead and rewrite what they are saying, but assign them to their respective variables. So we know that the first term, which we know in series, this is denoted as A. And we know that that is 7. So A is equal to 7. And the common difference, which is D, is 5. And they tell us that the series contains 20 terms. So the number of terms would be n. So we know that n is equal to 20. Given this information, we need to calculate the sum of the series. Well, we have everything we need to do this. To calculate the sum of the series, you know that in your formula sheet, you are given the sum formula. We can use this formula to find the sum of the series. And we're going to specifically use this since we know we have the value of D, but we don't have the last term. So it means that the sum of 20 terms is equal to 20 over 2 plus, and we have 20 minus 1, and then we will multiply that by D, which is 5. And you can just punch that into your calculator and find out what the sum of 20 terms would be. So the sum of 20 terms gives us 1090, and that is our answer to this question. Question 2.1.2 says the original arithmetic series is extended to 75 terms. Okay, let's go ahead and start annotating as we're reading through this question. So the original arithmetic series extends to 75 terms. So from 1 term to 75 terms. You see that they say it extends. So they are considering the fact that we know about this one. Okay, the one that only has 20 terms. So if we had the sum of 20 terms, we already know that. And they're saying this one extends to 75 terms. And the sum of these 75 terms is 14,400. So when you sum it up together, it gives you 14,400. But we know that when we summed up the 20 terms, it gave us 1090. Okay, so they say using sigma notation, write down an equation for the sum of the terms added to the original series. Okay, so the sum of the terms added to the original series. If this is the original series, and you can see that this extends to 75 terms, then the terms that were added would be from term 20 to 75. That would be the sum of the terms added to the original that they are referring to. They want us to write this in sigma notation, okay, the sum of those. Okay, so there are a few things that we would need to find. First of all, let's find out what exactly it sums up to. So we know what that sum, when we write it in sigma notation, what it should be equal to. So if this one adds up to 14,400 and that adds up to 1090, then the remaining part, that sum we're looking for, is going to be 14,400 minus the 1090. And this would add up to 13,310. So now that we know that, we just have to write it in sigma notation. So just remember the things that you need. Okay, we're saying the sum starting from a specific number and ending at a specific number. With this one, we can see where it starts from. If we know that from 1 to 20, that the sum of that is 1090, then it means that the sum that we are referring to starts after term 20, which is at term 21. So we start here at n equals 21 and we end at 75 terms. So all we need now is the Tn formula. So when we find that, we can put that in here and that would really just be our answer. Of course, with the sum also shown there. Okay, so let's find the Tn formula. So to find this Tn formula, we already know that A is 7 and D is 5. So using the general form of an arithmetic sequence, we'll say A plus n minus 1. So A is 7 plus n minus 1 multiplied by D, which is 5. And if you simplify this further, this is simply just going to be, we can start with the 5s because we will have an n. So if you distribute, you get 5n, and if you distribute, you get a negative 5. So that's negative 5 plus 7, which would give you positive 2. So we just have Tn is equal to 5n plus 2. So that would mean that our equation can be expressed like this in sigma notation, which is really going to rewrite it. So we have the sum starting where n equals 21 and ending at 75, and the pattern's formula is 5n plus 2, and that sum is going to add up to 13,310, and this over here is our answer. Question 2.2 says the sequence of the first differences of a quadratic pattern is 1, 3, and 5. So what they're saying is they have some sort of quadratic pattern. Okay, we'll call that quad. And the differences, the first differences are 1, 3, and 5. So you see how they come about. Okay, you take the next term minus the previous term to get the first differences. Then 2.2.1 says, if term 99 of this quadratic pattern, so that's in the quadratic pattern, if term 99 of that pattern is 9632, calculate the value of term 98. So this one is 9632. We need to find term 98. Okay, so from this, you see that to find term 98, because we know a little bit about the first differences, if we could find the first difference that is between term 99 and term 98, then we would know exactly what we need to add to this missing term to find this. And then with that, would be able to say this term minus whatever this term is would give us term 98. Okay, so the first thing is find exactly what this is. Okay, so what term number would it be in your linear pattern, your arithmetic pattern? Now, to find out what that is, you can kind of look at what is going on here. You see how we have term 1 and term 2? And if you say term 2 minus term 1 in the quadratic pattern, it gives you term 1 of your first difference. And if you say term 3 minus term 2 in your quadratic pattern, it would give you term 2 of your first difference. In the same way, term 99 minus term 98 would give you term 98 in your first difference. So we know that this is term 98. So if we can find out the value of term 98, we would be able to find out what term 98 is in the quadratic pattern. Okay, so finding term 98 shouldn't be a problem since we have all of this information. This is linear, it's arithmetic, so we can find its formula by saying Tn is equal to A, which is the first term, 1, plus n minus 1 times d. Now you can see the difference. If you say 3 minus 1, you get 2. 5 minus 3, you still get 2. So the difference is 2. And then simplify this further, it's going to be, we can just start here by saying 2n, and then minus 2, and you still have your positive 1. So the Tn formula is 2n minus 1. Okay, now remember we're trying to find out what exactly the value of the 98th term in your linear pattern is, in your first difference. So we are going to say to find term 98, we're substituting 98 in place of n. So that is 2 times 98 minus 1. This is like saying 200 minus 5, okay, because that gets doubled. So it's going to be 195. So term 98 is equal to 195. Okay, that helps us. Now that we know that this is 195, it means that you said this plus 195 because it's positive to get that. So in order to get term 98 back, you're just going to say term 98 is equal to, and you're going to take 9,632 minus 195 to get back to term 98, since you must have said term 98 plus this number to get term 99. And so therefore term 98 in your quadratic pattern is equal to 9,437. And that is our answer. Question 2.2.2 says, if it is further given that the third term of the quadratic pattern is 32, and we should probably put down the information as we see it. So let's get this up here so that we can fill that in. So we are told that the third term is 32. So now we know what the third term is, 32. If we are given that third term, determine the general term Tn of the quadratic pattern. Okay, so how can we find that? Remember that to find the quadratic pattern, you're really just looking for A, B, and C. Right now, we can actually find A by finding the second constant difference. So that would be 3 minus 1, which is 2. So let's just go ahead and equate these to the values they should be equal to. So this should be equal to 2a. 2a is equal to the first number here. Then 3a plus b is equal to this 1. And then, of course, that will be a plus b plus c. But we'll probably make another plan here since we don't have term 1. So our first equation is 2a is equal to 2. And so therefore that means a is equal to 1. And then the second equation is 3a, and a is 1, plus b is equal to 1. And so b is equal to 1. And if you multiply these together, they give you 3. Take it over, it gives you minus 3. So you can see that b is equal to negative 2. Now, to find c, we don't know what this is. So we can't really just substitute here. However, we can use what they told us. They told us that the third term is 32. So how can we use that? Well, they're telling you about a term value. So use it as a term value. And to use it like that, we would need to find the Tn formula so long. We know that it's an squared plus bn plus c. And so far we have a, which is 1, so that's n squared. And we have b, which is negative 2. So this is all we have and c is missing. We can use that information to find it. Since we know the third term is 32, term 3 is equal to 32, we will substitute this information into here. So we're saying T3. So in place of n, we're going to substitute 3. So we're saying 3 all squared minus 2 times 3 plus c. And we're saying specifically it's the third term that is equal to 32. So in place of term 3, we put 32. And so that's going to be 9. That's going to be minus 6 plus c. You know that 9 minus 6 is 3. And so if you take the positive 3 over, it becomes negative. 32 minus 3 gives you 29. And that is the value of c. So therefore, Tn is equal to n squared minus 2n plus 29. And that is our answer. Question 3 says, a circle with a radius of 6 centimeters is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally as shown in the diagram. So from this, clearly the bigger circle is the first circle drawn and it has a radius of 6 centimeters. So that is 6 centimeters. Then we have a smaller circle drawn. So that would be this circle over here, and it's drawn through the radius of this bigger circle and it also touches it internally. And then the third circle is drawn through the center and touches the second circle internally. So you can see what happens with these radii is you have a bigger circle with a radius of 6 centimeters. Then this circle, the smaller circle, the second one, the diameter is in fact 6 centimeters, okay, because it touches it internally, passes the center. If the diameter is 6 centimeters, then it means that its radius is 3 centimeters. And then, of course, the other one would also be half of this. So we can see what's happening to each radius of the circle. They just become half of what the previous circle was, or what the larger circle before them was. So the first question is to write down the radius of the third circle. Okay, so you know that the first circle was 6 centimeters. Then that gets divided by 2. And then the second circle's radius is 3 centimeters. And that would get divided by 2 to get the third circle. So we would know that the radius of the third circle would be 3 over 2 centimeters, since they just keep being divided by 2. And that would be our answer. Question 3.2 says, calculate the sum of the areas of the first 10 circles. Okay, so we are finding the sum of the areas of circles. You know that the area of a single circle is pi r squared. Now we need to find the area of the sum of 10 circles. So because pi would stay the same, and of course we're just squaring the radius, the only thing that changes is the radius. So we can look at what the sum of the areas of the circles would look like. So the first circle, because we know that the radius of the first circle is 6 centimeters, it would look like this. Area is equal to pi times 6 squared. And of course, that would simplify to 36 pi. And then the second circle would be a is equal to pi times the second one was 3 all squared. So that would be 9 pi. And then the third one would be 3 over 2 squared pi, which is just equal to 9 over 4 pi. And these will keep going. So that's what our pattern would look like. It would be 36 pi plus 9 pi plus 9 over 4 pi. And this will, of course, keep going until the 10th circle. Now we can see this is going to be a geometric series because of the repeated 9 we have on the numerator here. Plus, if you had to say 9 over 36, okay, you know that the pi's would cancel because it's really the same thing. 9 over 36 gives you 1 over 4. And if you said 9 over 4 divided by 9, it also gives you 1 over 4. So we can see here that the ratio would be 1 over 4. And then A, the first term, is 36 pi. And we know that the number of terms we're looking for are 10 terms. So we have everything we need to find the sum of these 10 terms. So we put down our sum formula. Now, using this formula is perfectly fine. You don't specifically have to use the one where r is less than 1, because what happens is the numerator becomes negative and the denominator, and so those negatives still end up cancelling. So this is perfectly fine. So let's go ahead and substitute the values of a, n, and r. So the sum of 10 terms is equal to, and our first term is 36 pi, multiplied by the ratio, which is 1 over 4 raised to the power of 10 minus 1 all over r minus 1, which is 1 over 4 minus 1. See how that becomes negative, and that also become negative. So they cancel regardless. And when we substitute that, the sum of 10 terms gives us 150 points. And if you round off to 2 decimal places, as we should, that will round up to a 10, rounding that up to an 8. So that is 150.80 rounded off to 2 decimal places. And that is our answer. Question 3.3 says, which circle has a diameter of 3 over 128 centimeters? Okay, specifically diameter. You know that we have been working with radiuses, okay, not diameters. So they're really just asking which circle has a radius of whatever this is and then divided by 2. Since our focus is not on the diameter, but rather the radius. So that part, half of it. So straight away, let's go ahead and do that. Say 3 over 128 and divide that by 2 to find out exactly what that radius would be. That would be 3 over 256. So that's what we will concentrate on. Okay, so which circle has a radius of 3 over 256? So let us look at our circles and find out what's going on here. With the first radius, we had 6 centimeters, then the next one was 3 centimeters, and then the next was half of that. So they kept being halved, okay? So in other words, they were being multiplied by a half. So to avoid any confusion, I'm going to actually call this a radius so we don't mistake it as a ratio. So first circle, the radius was 6, second was 3, third one was 3 over 2. So you can see that the previous term just keeps being multiplied by a half to get the next term, meaning your ratio is equal to a half. And you can see that the first term is 6. Okay, so we're trying to find out which circle would have this radius. In other words, which term in this pattern of the radii would have 3 over 256. So this is a TN question. We're trying to find out what is the term number belonging to this term value. So we can find that by finding the TN formula, which is TN equals A, which we know is 6, times R to the power of n minus 1. Now R is 1 over 2, so to the power of n minus 1. Looking for n, we're going to substitute in place of Tn 3 over 256. Okay, so it's equal to 6 times 1 over 2 to the power of n minus 1. And you see that 6 can leave over here. We can divide both hand sides by 6. So divide by 6 and divide by 6. But on your calculator, to avoid confusion, just say divide by 6. And we get 1 over 512, which is equal to 1 over 2 to the power of n minus 1. Okay, so you see that that's 1 over 2 and that's 512. So if you can express 512 as a base of 2, we would be able to solve for n. So we're going to take 512 and you can use this little trick on the calculator, say equal to and press shift and the factorize button over there. So that is 2 to the power of 9, meaning this can be written as 1 over 2 all raised to the power of 9. That would give you 1 over 512. So this is equal to 1 over 2 raised to the power of n minus 1. And now that our bases are the same, we can equate the exponents. So n minus 1 is equal to 9. And if you take the 1 over, n is therefore equal to 10. So this is the 10th circle. Okay, the 10th circle has a diameter of 3 over 128. You can conclude that. Okay, so the 10th circle has a diameter of 3 over 128 centimeters, and that is our answer. Question 4, we have been given f of x is equal to a to the power of x minus 1 for where a is greater than 0. And then we are also given a point b, which is 2, and negative 5 over 9. And this is a point on f. The first question, 4.1, asks us to calculate the value of a. Okay, you're given a point and you are given the equation of f. And the only thing missing is a. So let's go ahead and substitute this point. So we put in 2 in place of x and negative 5 over 9 in place of y. So that is going to be negative 5 over 9 is equal to, and then we have a to the power of 2 minus 1. Okay, so we've got a number over here and we also have a number there. So we can take the 1 over. When you take 1 over, it becomes positive 1, right? But you're subtracting by a fraction with a denominator of 9. And you need to make sure the denominators are the same. So we might as well call this 9 over 9. 9 minus 5 is 4, so that's 4 over 9. So we can just say this becomes 4 over 9 is equal to a squared. And now to get a on its own, you see that we just have to get rid of the square root. And we can do that by square rooting both hand sides. So when you square root in an equation, you have to consider the positive and the negative solution. So we have to include that. Meaning a is equal to either positive or negative. But remember what they said, that a, that base has to be greater than 0. So we will take the positive solution. So the square root of that is going to be 2 over 3, and that is our answer. Question 4.2 says, write down the range of f. Okay, so the range of a graph is all the possible y values that this graph can have. Okay, so for us to understand what exactly the range of f would be, we would have to understand what the graph of f sort of looks like. Okay, we don't have to sketch the entire graph, but understanding what it looks like, we know that it has 2 over 3 as a over there. But do you see that if we have 2 over 3 and then raised to the power of x minus 1, in front of this 2 over 3, the number in front of it, the coefficient, do you see that that is actually an invisible 1? Okay, because if you say 1 times this, it stays exactly the same. That's why this was like that. Because of that, that actually says a lot. When the value in front of that base, right, is positive, then, and we call that a really, then your graph is going to be above the asymptote. So regardless of whether it is increasing or decreasing, it will lie above its asymptote. Okay, so we know where it is, and now we have to find out where all its y values would lie. We can find out that by looking at this part of the equation. This part of the equation, so the general equation of an exponential function looks like this. It says a times b to the power of x minus p plus q, right? The q value tells you the horizontal asymptote. So Right now we can see that's -1. So that means you have that over here, the horizontal asymptote, it's a horizontal line. And so it's y equals -1. Okay, regardless of what it looks like. I'm not really saying what it looks like yet. So looking at this and looking at all the possible y values that this graph could possibly have, okay, if it had an x-axis over here and then this was the asymptote, do you see that there is no more graph below here? So the y values start at -1, right? -1 and then 0 and then 1 and then 2 and 3 and then everything else above -1. So we say that the y values for this graph are values that are greater than -1, not equal to -1 because there's an asymptote. The graph will never touch the asymptote. It just goes closer and closer to it. Of course, we can also write this in intervals. So that would be, because you're saying y is greater than -1, meaning you're starting at -1 and then looking at all the values that are greater than -1. So we'll say y is an element of, and we are starting not exactly at -1, but of course numbers that are greater than it, and then it heads towards infinity. And that would be our answer. You can either write it like this or like this. It's perfectly fine. Question 4.3 asks us to sketch the graph of f, clearly showing the intercepts with the axes and the asymptotes, if any. Okay, so with sketching graphs, it's better to actually just follow an order. So we can follow this order. First, we can consider the shape of the graph. And this is just what the graph looks like, as in, is it increasing, decreasing, where does it lie? Now, we know something about the shape of the graph from the previous question. We know that this graph lies above the asymptote. So regardless of whether it's increasing or decreasing, it lies above the asymptote. Now, all we have to find out is whether it is increasing or decreasing. Now, I know that there is this whole section that teaches you how to find whether the function is increasing or decreasing, looking at the a and the b value. But I'm going to actually work through this using a simpler method by simply just monitoring what the graph is doing at two x values. So we know what our graph looks like now. We know the a value, so this is what the graph looks like. You write down the equation of the function. F of x is equal to 2 over 3 raised to the power of x minus 1. And all you need to do is substitute an x value, really just two x values. You can choose 1 and x equals 2. And then you're going to just check what the y values do. Do they increase from this point to this point, or do they decrease? You see that when we substitute 1 in place of x, we get -1 over 3. And if you change that now to a 2, then you get -5 over 9. And all you have to do is compare. -1 over 3 is -0.3 recurring, and this is -0.5 recurring. So is it increasing or decreasing? It would be decreasing, okay? Because on a number line, you're looking at -0.5, which is like having 0 and then -1. And so -0.5 would be here, and then -0.3 would be here, okay? So you can see that it is generally decreasing because it went from -0.3 recurring to -0.5 recurring. Okay, great. We know it is generally decreasing. So it tells us that the shape of our graph should not look like this. This is increasing because when you read a graph, you read it from the left to the right. This is moving upwards. We're looking for the one that's going to be moving downwards, reading from the left to the right. So it is decreasing and it will look something like that. Great. We have the shape of the graph. Now, the second thing we'll consider would be the asymptote. Now, we already have the asymptote. We know that that is this over here. It's that horizontal asymptote. And it's a horizontal line, so it starts with y equals. So y equals -1 is our asymptote. And then the third thing we'll consider would be any intercepts. So this will be x and y intercepts. Okay, so to find out if there are any x-intercepts, you simply make y equal to 0. So if you made y equal to 0 here, making that equal to 0, you'd say 0 equals 2 over 3 raised to the power of x minus 1. And if you take this -1 over, you have 1 equals 2 over 3 raised to the power of x. And then we can solve for this using log. Okay, so we're going to make x the subject, the exponent becomes the subject, and we say log, and then we fill in the base here, 2 over 3, and then whatever that exponential expression was equal to. So let's see what that is. We see that x is equal to 0. Okay, this is a very important type of intercept. You see, it's equal to 0. That's the x-intercept. The x-intercept is where y is equal to 0. But the y-intercept is where x is equal to 0. But we can see that x is 0 already. So this means this has one single intercept. It's really just the x and y intercept are the exact same thing. They're just 0 and 0. Okay, so this graph, we already now have the things that we needed in order to find this graph. So let's go ahead and sketch it. You do not need a whole lot of points. You just need to put down the general shape of this graph. So the main thing that is going to help you to find the shape of the graph really, or know what it's going to look like, is your asymptote. And you know your asymptote is y equals -1. So we're going to draw a horizontal line, and that's going to be our y equals -1. I will make it dotted since it is an asymptote. Okay, and we know the shape of the graph, and we know that it passes the origin 0 and 0. So we're just going to draw. Yeah, just make sure you put that point and make sure that it is clear. And the graph is just going to decrease, get closer and closer to the asymptote, but never touch the asymptote. Okay, so something like that, and it's going closer, but never touches it. And this is our graph F. Okay, so that is what our graph looks like. For reference, just because they did mention this point, we can't just go ahead and put B. B was 2 and -5 over 9. So it's 2, meaning positive on the x-axis and then negative on the y-axis. So you can't just like there and then say that that is B, 2 and -5 over 9. Okay, and that is what our graph looks like. Question 4.4 says, it is further given that C is a point on F at y equals 19 over 8. Determine the coordinates of C prime, the image of C when C is reflected about the line y equals x. Okay, so we are first given this point C, which lies at y equals this. So this means that it lies on F, yes, sure, but its y value is 19 over 8. Since it lies at the point where y equals 19 over 8. So C currently looks like this. It's x and 19 over 8. So let's first understand the end goal before we can actually tackle this question. The main goal is they want you to determine the coordinates of C prime. And C prime is a reflection through this line y equals x. When you reflect a graph or a point through the line y equals x, you're really going to find the inverse of that point. And how inverses work, let's say we had a point 1 and 2. If this is a point A and it was reflected across this line y equals x, then the inverse of that point, the x and y values simply just switch places. They swap. So it's going to be A prime will be 2 and 1. Okay, so we have an idea of what we need to do. We know what C is. We need to find C prime, the reflection. So the main goal is to find out what x is so that we can just switch these two around, and that will be C prime, the reflection about the line y equals x. Okay, so let's go ahead and find x. Now we know what our function looks like, and we know that the y value is that. So all we have to do is find that x value. F of x is equal to, we know that this is 2 over 3 raised to the power of x minus 1. So to find the missing x, substitute your y value, meaning we have 19 over 8 equals 2 over 3 raised to the power of x minus 1. Then we can take this -1 over. You see, when it comes over, you can use a calculator. Give you 27 over 8 is equal to 2 over 3 raised to the power of x. Now, because this is an exponential equation, to better understand this, let's write these as prime bases. So the base is going to be a prime number. 27 can be written as 3 to the power of 3, while 8 can be written as 2 to the power of 3. Notice how both exponents are 3, which is going to be very useful. So right now we just have 2 over 3 raised to the power of x. It's almost the same. The bases are almost the same. The only problem here is this is 3 and that's 2. But we can fix that. Here's what we can do. Why don't we take the 3 and move it to the denominator? and then take the 2 and move it to the numerator. But of course, there's going to be a consequence for this. If you move the 2 to the numerator, the consequence is that the exponent becomes negative. So now we have 2 to the power of negative 3 over 3 to the power of negative 3. And this is equal to 2 over 3 raised to the power of x. So because they have the exact same exponent, we can just rewrite this as 2 over 3 raised to the power of negative 3. And now do you see that their bases are exactly the same? So this therefore means that x is equal to negative 3. Okay, now that we know what x is, we can fill that in there. And so that would explain what c prime is. I'll just put that over here. So it means that c is therefore negative 3 and 19 over 8. And that would mean that c prime, the reflection across y equals x, would be 19 over 8 and negative 3. And that is our answer. Okay, we have question 5, and question 5 says, sketched below is the graph of f having the domain negative infinity to 1. Okay, so it's going like that, and from 1 to positive infinity. So we can see that is clearly happening because of our asymptote. The graph of f cuts the y-axis at 0 and 1, and then we also have a line of symmetry of f, which is given by the equation g of x equals x minus 3. And the first question is to write down the value of p. Okay, so what does their p say? Do you see that their equation says f of x equals a over x plus p? But we know the general form of a hyperbolic equation doesn't look like this. It says a over x minus p plus q. So you can see that our p here, what we know to be p, is different to what they are asking for here. So let's just make sure we don't get confused with that. So when looking for our p, this in the general form, we know that that is the vertical asymptote. That is the x value of the vertical asymptote. We say x equals p, right? So we can see that it passes 1. So x is equal to 1. The p that we are referring to in the general form is 1. And if you substitute that there, you get y equals a over x minus 1 plus q. But remember, we're not trying to solve for this p, we're trying to solve for this p. So this says we have x plus p. So if you had x plus p, what do you have to add so that your equation still ends up looking like that? Because we know it should look like this. What should you add? You should add a negative 1. If you add that, you end up with an x minus 1. That's the p that they are referring to. So the p over here is p equals negative 1, and that is our answer. Question 5.2 says, determine the equation of the horizontal asymptote of f. You see that that is this over here. Now, we would have been able to find this using the equation of this function, but the problem here is we don't have a and we don't have q. So you see that there are two things missing, meaning you need 2 points to be able to find this. In other words, you're trying to form 2 equations, and that will help you solve for 2 missing variables. But we don't have that. So let's look at this line. You see how it runs through here, and then it passes this line, which we have the equation of, this axis of symmetry. So to find that y value, we simply have to substitute an x value, and you can see what the x value is. The x value is 1. It is that x value that your asymptote passes through, your vertical asymptote. Okay, so let's go ahead and do that. We're going to take the graph of g, and we're going to substitute 1 into it. The graph of g is x minus 3, so that is just 1 minus 3, and g of 1 is equal to negative 2. So the equation of the horizontal asymptote, remember it is a horizontal line, so it is y equals negative 2, and that is our answer. Question 5.3 says, calculate the value of a. Okay, we have enough information now. Since we know the horizontal asymptote is y equals negative 2, we can fill that in here and fill in the p value, and we can just substitute 1 point that we have to find this. So our equation so long is f of x equals a over x minus 1 minus 2. And we're going to substitute the only point that we have, which is that y-intercept 0 and 1, okay? And so this is going to be 1 is equal to a over 0 minus 1 minus 2. Might as well just take this over already. When it goes over, it becomes positive and adds to the 1, which is 3. So 3 is equal to a. 0 minus 1 is negative, so that becomes a negative a when it divides by negative 1. Therefore, a is equal to negative 3 if you multiply both hand sides by negative 1. And that is our answer. Question 5.4 says, for which values of x is f of x greater than or equal to 0? Remember, f of x refers to the y values of your graph. It's the same thing as saying, because you see how we had there, we had f of x is equal to, and we had our equation, right? If I had said y here, it would still mean the exact same thing, okay? We just call it f of x because it's to name that particular graph. So we can always assign an equation to that particular graph. So we're looking for where the y values are either greater than or equal to 0. So let's look at our graph. You see, here's our graph, and let's look at the y-axis because these contain the y values. The y values are greater than 0 all through here, okay, and equal to 0 right there. Everything below here is less than 0, so you will not consider any part of the graph below here because they will all have negative y values. So we're only going to focus on parts that lie above here. In other words, above your x-axis. Okay, let's highlight the parts of the graph that lie above the x-axis. That would be all through here. Of course, it shoots up like that. So it goes like this and then all through there, moving up. Okay, so we know where it starts. It starts at this point here, at the x-axis. At the x-axis, this is where your y value is 0. And then it's all through here. So if you map these down to the x-axis to better understand where these x values are, at this point over here, this is an x-intercept. We would have to find out exactly what that is, okay? Because it's not 0. 0 is here. This is the origin. This is that. So let's find out that x-intercept over here first. Where is your y value equal to 0? Okay, we're going to take the equation of our graph and then make y equal to 0. We know that a is negative 3, and if y is 0, then what will this be? Okay, so straight away you can take your negative 2 over, or just take this over. I mean, it's going to become positive. So this is now 3 over x minus 1 is equal to negative 2. Okay, then you can just cross multiply. So you're going to multiply this with this, but this has two terms. So you need to multiply this number with the x, which is going to be a negative 2x, and then with the negative 1, which is going to be a positive 2, is equal to, and then the 3 multiplies with the invisible denominator of 1 here. Okay, and that's 3. Now we have this is negative, so we might as well take it over to make it positive, and then you have 2, and that comes over and becomes a minus 3, which is negative 1. So if you divide both hand sides by 2, x is therefore equal to negative a half. Okay, so that's what we really need there. Now that we know that this over here is negative 1 over 2, it means the values of x for which f of x is greater than or equal to 0 would be where x is greater than or equal to negative 1 over 2. Okay, moving like that, but less than positive 1. Not equal to positive 1, because at positive 1 we have an asymptote and our graph will never pass the asymptote or touch it. So our answer looks like this. We can just say, therefore, this means that x is greater than or equal to negative 1 over 2, but less than 1. Okay, if you want to write them as intervals, you can write it like this. So you're going to say x is an element of, and you're going from negative 1 over 2, right, all the way to positive 1. But here, because we have that x is greater than or equal to negative 1 over 2. Negative 1 over 2 is an included value here. So you're going to use a square bracket. And then positive 1 is not included. It's just values less than 1, not equal to 1. So we use a round bracket. And you can leave your answer like this or like that. And that would be perfectly fine. Question 5.5 says, graph f undergoes a transformation to h where the domain and the range of h are the same as that of f. Okay, so there are a number of transformations that you probably didn't do to make that happen, to make the domain and the range stay exactly the same. But then they also say h prime of x, the derivative of h, is negative on its domain. Okay, you see, this is a hyperbola, and I know you're probably thinking, but now they're asking for the derivative of h. Remember that derivative, right? All it means is gradient, okay? So the derivative of h is referring to the gradient of h, and it's saying that the gradient is negative. Okay, so what does it mean for a gradient to be positive? If a gradient is positive, then it just means that the function is increasing. Okay, that's why it has a positive gradient. So when you read from left going to right, the graph moves up. When the gradient is negative, it means that the function is decreasing. So what they're saying is the function is decreasing on its domain. So when we're looking at it, looking at the x values from left to right, that graph must be moving downwards. Okay, so describe a possible transformation that f could have undergone to result in h. Let's look at our graph. So we know domain and range stay exactly the same. And the second thing we know is that h prime of x is going to be negative. Okay, do you see what the graph of h is doing right now? So on its domain, it is moving upwards. It's increasing. See, that wing is increasing and this wing is also increasing. Okay, all through. What they're telling us is that the new graph starts to decrease all through. So it's supposed to move down and down like that. Okay, they're both moving down, reading from left to right. But at the same time, the domain and range should stay exactly the same. Okay, let's look at the possible transformations that could have happened. Immediately, we see that this starts to decrease. The only way that that could have happened is if a reflection happened. Okay, so you see this wing over here? If it was reflected, then it would move downwards. This wing, if it was reflected, it will also look like that. It just forms a mirror image. But we need to maintain the domain and range. The only way we can control the domain and range is through the asymptotes in the hyperbola. So we need to ensure that these asymptotes do not change. You need to stay exactly the same. Okay, so one way we could have actually transformed this new graph is by reflecting it through this line. So look at this line, x equals 1. If you reflect it through this line, look at what happens. It's going to stay exactly the same. Okay, a mirror image or reflection is really just whatever this is, right? From this line. If you went from here and you went a specific amount of units to the left, you're going to go from this line a specific amount of units to the right to get to that next point. Same thing over here. I went from this line to this. Okay, that specific amount of units. I will do the exact same thing here. And that's how we create a reflection. So we know what that looks like. That is going to end up looking like that. And that would maintain the domain and the range because nothing will happen to them. So this one would just be reflected. It will just do whatever it's doing here. It will just do across this line. So like that. Okay, so that is one way and we can put that down. There are probably a number of ways that we can do this. Okay, so I'm going to put the first one down. It is a reflection across the line x equals 1. Okay, so f is reflected about x equals 1 to obtain h. That is the first option. Okay, let's look at a third way of doing this. So if we remove that, what is another way we could do this? Well, we can follow the whole trend that the gradient should be negative, meaning our graph needs to decrease, right? It was increasing here, and to immediately make it decrease, you could have simply reflected it across the y-axis. So here's your y-axis. If you reflect that line across the y-axis, it's going to look like this. Now, it's not exactly the same, but we can make adjustments to this. So you see, if this is over here, it's reflected across the y-axis. So it's going to appear here, and then it's going to do that, and then it's going to both meet at once since this is the y-axis. So again, reflect this across the y-axis. It's just going to appear like if you have from here and you went this distance to get to this point, you're going to go from the y-axis that same distance to get to this point. So it ends up looking like that. Now we're not done. Sure, it is decreasing, but the domain and range will not be the same. If you reflect it here, what happens is the domain that used to be x equals 1, the asymptote that used to be x equals 1, will not be that anymore. Reflecting things across the y-axis causes all the x values to change, meaning all the x values get multiplied by -1. So this that was 1 will now be -1. What we could do so that it ends up looking like the reflection and the domain and range are still the same, you could take this and shift it so that it lies directly on this asymptote. That way the domain would stay exactly the same. Okay, so the range didn't change yet. We didn't change the range. We just reflected across the y-axis. So this would move and you would move it till here. So you must have moved it from -1 to +1. You moved it 2 units to the right. And then that would actually sort that out. Then your graph would also move along with it because the whole graph is moving. Okay, so it also moves 2 units to the right and then it looks like that. This part will also do the same thing, 2 units to the right, and it'll look like that and still not touch that. Okay, so with this one, there's 2 things you would have to do. You would have to reflect it across the y-axis and then shift it 2 units to the right. Okay, so f is reflected across the y-axis and shifted 2 units to the right. And to follow a more, graph terminology, instead of saying shifted, you could say translated. And those would be the possible answers to this question. Question 6 says, in the diagram below, the graphs f of x, which is equal to that, and g, a straight line, are drawn. So we have a parabola and a straight line. C, which is 3 and 8, is a point of intersection of f and g, as we can see. EH is drawn parallel to the y-axis. So it is a vertical line with E a point on F and H a point on G. And the first question asks us 6.1 to calculate the coordinates of B, the turning point of F. So find the turning point, which is this. You can see that they gave us our equation in standard form. So when finding the turning point in standard form, we use this equation. So this will find the x value. X equals -b over 2a, and we're going to substitute our b and our a value. So that is going to be, as you can see, a is -1 and b is 4. So x equals negative and then 4 over 2 times -1, which means they're both negative. So that's just 4 divided by 2, which is 2. Okay, so we have the x value, and now we can find the y value by simply substituting that x value into the equation. So f of 2 is equal to, and we'll have -2 squared, so -2 all squared plus 4 times 2 plus 5. And therefore f of 2 is going to be equal to, these two together give you 8 and 5, that's 13, minus 4, 13 minus 4 is 9. So that is our answer over there. So B is 2 and 9. And that is the answer to that question. Question 6.2 says, show that the equation of the line through A and C is given by g of x equals 2x plus 2. Okay, so through A and C. You can see that if it goes through A and C, we just need these 2 points to find the equation. So A is missing. And as you can see, A is also the x-intercept, one of the x-intercepts of the parabola. And at the x-intercept, you know that y is simply equal to 0. So let's go ahead and do that. This is the equation of the parabola, and we'll set it equal to 0. Okay, at this point, you can multiply both hand sides by -1 to get that to become positive, or just bring them over. So we have x squared minus 4x minus 5 equals 0. And now we factorize. So equal to 0, x multiplied by x gives you x squared, and factors of 5, that can give you a 4. Okay, factors of a -5. 5 is a prime number, so it's just 5 and 1. And which should be negative so that we get a -4 in the middle. It should be the 5. Give the negative to the bigger number. Okay, so this is x is equal to 5 or x is equal to -1. So now we can choose. Which would it be? This is A and this is D. They're both x-intercepts. So it's clearly the -1 that we're going to use here. and then that would be the 5. Okay, so this is finally a is -1 and 0. And now we can use this to find the equation. So we know what c is. C was 3 and 8. And we can just find the equation of this graph now. So it is a straight line, meaning we need to find the gradient first. So gradient and then the formula for gradient. When subtracting, just make sure you are consistent. If you're going to say top minus bottom, you need to do the same thing with the x values as well. So this is going to be the gradient of AC is 0 minus 8, top minus bottom, over -1 minus 3. We know that 0 minus 8 is -8, and that gives you -4. So -8 over -4 is +2. So that is our gradient. And now we just have to find c. So you can use y equals mx plus c, or use this equation. So we'll say y minus y1 equals gradient times x. But we already know what the gradient is. It's 2. So times x minus x1. And then substitute a point. Choose the easier point. So I'll take a. So this is going to be the x1. That is the y1. So this is y minus 0 equals 2 times x minus -1, which of course multiplies and gives you a +1. So y minus 0 is y is equal to, and then distribute, it's 2x plus 2. So that is g of x. G of x is simply equal to 2x plus 2. And that is our answer. Question 6.3 says, calculate the maximum length of EH for where f is greater than g. Okay, so in our graph, the length of EH where f is greater than g. Do you see that E lies on f? Okay, so that represents f. And then h lies on g. So where f is greater than g, so that just means that the y value of f is going to be greater than the y value of g for EH when we want to find the length of EH. Okay, so you're simply going to say f of x minus g of x. Take that y value minus this y value, and it will give you the length of EH. Of course, this will be in terms of x at first. Okay, so we're taking the graph of f and subtracting by the graph of g. So to find EH, we say f of x minus g of x, and we're going to say this is equal to, and we have negative x squared, all of that, minus the g graph. But remember that this is going to be put in brackets, so it'll be 2x plus 2, and if you distribute, they become -2x minus 2. So this is equal to, and now just put your like terms together. So those two, they give you +2x, and 5 minus 2 is +3. Okay, so this is the length of EH. It's not the maximum yet, it's just the length. So now to find the maximum, do you see that the length of EH is in the form of a parabola, a concave down parabola specifically? To find the length, all of these, right, at different points, it's going to tell you the length of EH at different x values. But we're looking for the highest, the maximum, which happens right here. And we know that this point is the turning point. So all we have to do is find out exactly what is the y value of the turning point, because they want the maximum length. They don't just want the x value at which it's a maximum. Okay, so let's go ahead and do that. So in this one, you can decide to still use x equals -b over 2a, or you could derive, and that's perfectly fine. So I'm going to derive. If you derive that, and again, you're going to derive it and set it equal to 0, because at the turning point, your gradient is 0. So to find the gradient, you derive the function. So deriving that, it will be -2x, coefficient times exponent, exponent minus 1, and plus 2. And we'll set that equal to 0. Okay, so since this is going to be positive, if you take it over, you might as well say 2x equals +2. And then if you divide both hand sides by 2, x is therefore equal to 1. So we now know the x value at which it's a maximum. We have to take that and substitute it into the equation of EH so it can find out the actual length, the actual maximum length. So the maximum of this is going to be negative, and we'll say 1 all squared plus 2 times 1 plus 3. Okay, so this is equal to, and these together give you 5. 5 minus 1 is 4. And we can just conclude the maximum length of EH is 4 units. And that is the answer to that question. 6.4 says, given k of x is equal to f of x plus m. Okay, so a translation is happening here. So you can see that it's affecting x, meaning it is a translation either to the left or the right. Here's the thing. If you have a point or even a graph, and let's just say this point is 1 and 2, right? If you're adding or subtracting to the x, do you see that if I added to the x value over here, that this point will either move to the right or to the left? Okay, so adding to the x moves the graph to the right or left. But after that translation, it's equal to all of this. And they want us to determine the value of m such that g is a tangent to k. Okay, so the graph of f gets translated and it becomes k. And we need to find out the value of m for which g will be a tangent to k. Let's visually understand what's going on. We knew that the graph of f was a concave down parabola, and the graph of g was a straight line, an increasing straight line. And what they're saying is the graph of f is going to be shifted, either to the left or the right, but then it gets shifted in a way that it is a tangent to g. Okay, so we can just look at the possible ways it could be shifted so that it's a tangent to g. So if this is what the graph looked like and it was here, let's try shifting it to the left. You see what happens here? If you shift it to the left, at no point does it ever become a tangent. It's not a tangent over there. Tangents do not intersect lines. They kind of like graze the line. If you have a curve, circle, any type of curve, and you have a tangent, it does not intersect. It simply just touches one point briefly and then exits. That's really what it does. And at that point, the gradients will be exactly the same. Just like we can see, this parabola is decreasing here, then it hits a turning point, and then it starts increasing. In the same way, this graph is an increasing function. So at some point, the gradient is exactly the same. Okay, so with that being said, you can see that it will never be a tangent to the graph of k, the new graph, if we shift it to the left. This is never going to happen. It just constantly intersects the graph of k. Okay, so we're not going to shift it to the left. We will shift it to the right. Look at what happens when we shift it to the right. As we shift it, eventually it sits like that and it will intersect the graph of g. Okay, so there it's just briefly passing it. So this would be k, meaning it's going to shift to the right, and then we can see what that is. Okay, we'll just keep this visual on the side just in case we'll need it to, understand anything. So this is what we end up with. Clearly, we're going to have to deal with more of the algebra of this because it's 5 marks and they wouldn't give you all of this for nothing. So let's see, how can we make this possible? How can we ensure that g becomes a tangent to k? Okay, let's just look at a few things. You see, if it is a tangent, the first thing that we'll see is that it intersects with the graph of g, meaning at some point k of x will be equal to g of x. But now what we can do is take advantage of the fact that this forms an equation, and it's going to be a quadratic equation since k is quadratic, okay? K is quadratic because it's a shift from f, which was already a parabola. So we can manipulate the amount of intersections it will have by manipulating the discriminant. So here's what we can do. Because they intersect, we can ensure that the discriminant, okay, b squared minus 4ac, is equal to 0. Here's the thing about the discriminant. With a parabola, you know that if the discriminant is greater than 0, you will have two unequal roots. So this is something like x minus 1 and x plus 3, for example, right? Two unequal roots. But if you make delta equal to 0, what actually happens is you're getting equal roots. So it's something like x minus 1 and x minus 1. And do you see that these are actually the exact same numbers? So you end up with one root. And that's what we're trying to do. We're going to equate these two graphs and then ensure that the discriminant is equal to 0. And that would ensure that they intersect at one point only. Okay, so let's do that. We're going to focus on finding k of x being equal to g of x. Let's simplify that. So k of x, we already know what that is. It's all of this. So we'll make it equal to g of x. And we know that g of x was 2x plus 2. So all of this again will be rewritten, and then we're going to take g of x over, these over. So they will come over and become minus 2x minus 2 is equal to 0. And let's just put our like terms together now. So negative x squared, and these two go together, becoming a positive 2x. You might as well write this with this, because do you see that it just has a coefficient, but the variable that we have is x. So we're going to put them together because they will still be like terms even if they can't add right now. So we have minus 2mx, that's done. And then the constant, because that's all that's left. So that would be your negative m squared, and then your plus 4m, and 5 minus 2 is positive 3 is equal to 0. And this is what we have. Now this equation, all we have to do in this equation is ensure that the discriminant is equal to 0. Okay, how do we find the discriminant? The discriminant is, remember, that part of the quadratic formula that says b squared minus 4ac. We'll make that equal to 0. But of course, for us to do that, we need to be able to see b, a, and c. Right now, a is clear. It's the coefficient of x squared. Here's x squared. It's the only x squared. The coefficient is clearly negative 1. But here, it's not easy to see yet. So let's just make some adjustments to that. Here's what we can do there. We leave this as negative x squared. And then with this, because they both have x, it's like taking out x as a common factor. You could write it like this, x, and say what is left here. You're going to have 2 and then minus 2m. So this now becomes the coefficient of x, which is b. Okay, and then the constant is just everything that does not have x in it, which would be all of this. So that's minus m squared plus 4m plus 3, and then we have is equal to 0. So we know what a is, we know what b is, and we know what c is. We can substitute it and find out what this will be. So this is where b squared, which is 2 minus 2m, so 2 minus 2m, all squared should be, and then minus 4a, which is negative 1, and then c, which is negative m squared, plus 4m plus 3 is equal to 0. And now we can simplify this. So this is going to be 2 all squared, which is 4, negative 2 all squared, which is positive 4m squared. And then 2 times negative 2m is negative 4m, but you multiply that by 2, giving you negative 8m. And here, when we multiply these two together, they give you a positive 4. And that's going to distribute into here. So it's 4 times negative m squared, which is negative 4m squared, 4 times positive 4m, which is positive 16m, and 4 times 3, which is positive 12, is equal to 0. Okay, so this is what we have. Okay, great. Do you see how 4m squared and 4m squared would cancel? And all you're left with here is the negative 8m and 16. 16 minus 8 is 8. So that's 8m. And we have 4 plus 12, which is 16. So plus 16 equals 0. And then you can take that over. So 8m equals negative 16. And divide both hand sides by 8. Therefore, m is finally equal to negative 2. And that is our answer. M should be equal to negative 2, so that G is a tangent to K. Mary's grandparents deposited 5,000 Rand into a savings account on the day she was born. The account pays interest at a rate of 6.8% per annum compounded quarterly. Calculate the accumulated amount in this account on Mary's 16th birthday. Okay, so looking at a timeline of what's going on, one amount is being deposited, which is 5,000 Rand. So when Mary is born, they deposit money into the account, and then this money stays until she is 16 years old. So you can see that this is for 16 years. But they tell us that it's compounded quarterly. So the money is going to gain interest every quarter. So yes, the years may be 16, but you need to convert it into quarters. So which is times 4, which is 64 quarters. Okay, so we can see that this is a case of compound growth. Money is being deposited once and then it grows for 16 years or 64 quarters. So we're going to use the compound growth formula, which is A equals P times 1 plus I raised to the power of N. Okay, so you can see that we are looking for the accumulated amount, A. That's what we're still looking for. P is the amount that was deposited or invested. They deposited 5,000 Rand, so that's 5,000. And then 1 plus the interest is 6.8%. So you can put that in decimal form straight away, which is 0.068. But remember, this is compounded quarterly. So if you just put it like this, it's going to be compounded per annum, meaning it will only gain interest every year. So you need to divide it by 4 so that it gains interest every quarter. And then we raise it to the power of not just 16, but 64, since it's going to gain interest for 64 quarters, which is a total of 16 years. Okay, so we'll just put this on our calculator and find out how much will be in Mary's account. Okay, and we get 14,706 Rand, and that rounds up to 56 cents. Okay, so that is the answer to this question. Question 7.2 says, after 4 years, the value of a printer was half its original price. Okay, so it had a specific price and then became half. Determine the rate at which the value of the printer depreciated over this period, if depreciation was calculated according to a straight line method. Okay, so just use the straight line depreciation formula, which is A equals 1 minus I times N. And then we're looking at the price of this printer, okay? Where it started off, it was a specific amount. Let's just call that X. And then it ended up being half the amount it initially was. So the A can be a half X. And the interest is what we are looking for. And N is exactly 4 years, okay? And remember, it's not compounded because it is straight line. So we can just say a half X is equal to X. And then 1 minus I multiplied by N, which is 4. Okay, so we're just looking for the interest. So how do we get closer to the interest? We can get rid of the X. Now we know that the X is not 0. So in this case, it's okay if you want to divide by X because it's not 0. Okay, the printer doesn't cost nothing. Okay, so in this case, we're just going to get rid of this X by dividing both hand sides by X. And now you have a half. And that breaks open and you have 1 minus, those multiply and become 4i. So we're still looking for I. How do we get to I? We can get to this by taking this over since it's already negative. So it's now positive 4i equals, and we still have 1 here. And then we can bring the half over and it becomes negative. So this will become a half and you have 4i. So if you divide a half by 4, and that is, so I is finally just equal to 0.125. And so you have to put that as a decimal. So multiply that by 100. And so the interest rate is just 12.5%. And that's our answer. Okay, so it must have depreciated by 12.5% per annum on straight line method. Question 7.3 says, Tsepo was granted a loan of 100,000 Rand on the 1st of March 2022 at an interest rate of 13.5% per annum compounded monthly. Tsepo agreed to repay the loan over 5 years in monthly installments. So he's going to pay them back monthly over 5 years and in monthly installments of 2,398 cents starting on the 1st of April 2022. That makes perfect sense. So he opens up or starts this loan right on the 1st of March, 1 March 2022, and then he starts paying on the 1st of April. So that's following the normal order of a loan. You request for a loan and then you start paying 1 month later. But the main point here is to find out the interest, because they say calculate the total interest he will pay over 5 years. So how do we find the interest? Well, interest is the extra money you are giving the bank. So what happens here is to find this interest, you can look at interest like extra. Let's just find out how much he gives them extra, because this whole story is about Tsepo giving back that money to the bank. But he's of course not going to give them 100,000. He's going to give them more. So when we're looking at the interest, how much did the bank give him? The bank gave him 100,000 rand. Now, how much did he give the bank back? And you can actually just compare which one would be bigger. If they gave him a loan of 100,000 rand, right? Would he pay back more or less? He will obviously pay back more because of interest. So we know that we need to find out how much Tsepo pays back and then subtract that by how much he borrowed, which is 100,000 rand. Okay, so let's find out how much Tsepo pays them. So every month he gives them 2,398 cents. And he does this for how long? For 5 years, right? But he doesn't just give them 2,300 every year. He gives them this every month for 5 years. So this is times 12 months in a year and 5 years. And then we will subtract this by the amounts they actually gave him. So this is how much he pays back, and this is how much he borrowed, and the difference will be the interest. Okay, so that's minus 100,000 rand. Let's find that. And we can see that that amount, the interest, will be 38,058.80 cents. So that is how much interest Tsepo is going to end up paying throughout these 5 years. Question 7.3.2 says Tsepo paid 22,398 cents, his monthly installment. So this is his monthly installment and an additional 20,000 on the 1st of March 2024 into the loan account. He continues to pay the original monthly installment thereafter. How many months earlier will Tsepo repay the loan? So with the extra payment he makes, they just want to know how many months earlier will he repay the loan. So we're probably going to need this timeline so we can understand what happens on different dates. Okay, so we know that this loan starts on the 1st of March 2022, but it lasts for 5 years. So it means that it will end on the 1st of March 2027. Okay, and what happens is he makes a monthly installment on the 1st of March 2024. So this means that he was making all of these other installments, but on the 1st of March 2024, he makes this payment that he normally makes every month and an additional 20,000. So this plus 20,000 rand that he makes here. Okay, I'll just put it down here. So after he makes this 20,000, we need to find out how much earlier he's going to finish since he's making this 20,000 so that he can speed up his payments of this loan. Okay, well, we know he gave 20,000 extra, but we're going to have to find out how much he owed at this point because he makes a payment and then he pays 20k extra. So how much did he owe at this point? Now you see the present value formula. What it helps you to do is to find out how much is being owed, how much the person owes at different times. So it's going to be useful here. We can find out exactly how much Tsepo owes here and then remove 20,000 since he has paid this upfront. Okay, so let's get our formula down. So we are looking for how much he owes. So PV is still going to be present value is still left empty. And we know he continues paying this amount, right? That's 2,398. So that's 2,398 is monthly installment. And then we'll say 1 minus 1 plus the interest there, 13.5% per annum, compounded monthly. So that is 0.135 over 12 because it's compounded monthly. Now, here, this is where we're going to have to think about it. So negative what? What goes here? Do you notice that in the future value formula, that n is not negative, it's positive because in the future value, that n stands for the amount of payments that you have made, right? But in present value, it's negative. This is because it stands for the amount of payments you still have left to make. So if we're trying to find out how much he owes on the 1st of March 2024, do you notice that that is exactly 2 years after this loan was borrowed? So if it's exactly 2 years, then the amount we'll put here is the amount of months or years, months really, that he has to pay off this loan. After 2 years, he has how long left? So after 2 years, because this is a 5-year loan, he has 3 years left to pay. So that's what we're going to put here. It's not going to just be 2, it's going to be 3 because he has 3 years left. And of course, it's times 12 because it's compounded monthly. So 36 months to go. then over, of course, the interest, which is 0.135 over 12. Okay, so let's put that on a calculator and find out how much that is. And you see that after 2 years, when he has 3 years left to go, he owes exactly 67,804.9364. Now, I won't round off because I'm just trying to get the exact amount. So this is how much he owes. But what happens on this day? He also goes and makes an additional 20,000. So if he owed this, we will remove 20,000 to find out how much he now owes. So he owes this amount minus 20K. So this is going to be 47,000, again the same thing, 804.9364. Okay, so now we know how much he owes. So what happens here is that he's going to start paying the same amount that he was paying before. But now he no longer owes this amount. He owes a new amount. And so the month after and every other month after, he starts paying 2,398. And so now we have to find out how many months earlier will he finish paying off the loan. So to find out how many months earlier, we need to find out how long it's going to take him from here to finish paying off this loan. We know now this is the new loan. So again, we're going to use the present value formula. Okay, so here's our present value formula again, and we're also still looking for n. X is going to be that 2,300 because he continues paying that. So we're saying if he now owes this, present value is always for the money owed. So if he now owes this and he's paying 2,300.98 cents, and we have 1 minus 1 plus 0.135 over 12 raised to the power of negative n. Now I won't multiply that by 12 or anything. Let's leave it like that so that it can tell us the months that he's going to pay this or finish this loan in. Okay, and that goes all over 0.135 over 12. Okay, so here we have an equation and we need to solve for the exponent n. We can start by getting rid of this denominator. So we can multiply by that number. So you're multiplying on both hand sides because it's an equation. So by 0.135 over 12 on both hand sides. And on your calculator, you're just multiplying that number by 0.135. So you can just go multiply by 0.135 over 12 so that we don't round off. Okay, and this is what we get. So when we do that, we get 537.8055, and I'm just not going to round off. Now that that happens, what happens here is these would cancel because they're the same thing, and you're just left with everything here. Okay, and then at this point, we can get rid of this now because this is the next thing that will be stopping us from getting closer to that n. So it's decimals, and we'll just leave it like that. 2337 ... Just don't round off. And what happens here is these ones would cancel. So now they're gone, and you only have what is here, which is just a 1, and then 1 plus 0.135 over 12. So this is just calculation. You just have to be careful at this point. Okay, so now we are almost there. Do you see that this is negative? So we might as well take it over. When you take it over, it becomes positive. And now you see the negative in front is gone. And you leave it to the power of negative n still. Then this is equal to 1 minus, and we're going to subtract that by 1. Okay, so 2337. And how we'll do that on the calculator is using this ans button. So you see how we needed to say 1 minus that number? You can just say 1 minus ans, and that was already recorded. So you still have this 1 plus 0.135 over 12 raised to the power of negative n, and is equal to 0.7662, and that keeps going. Okay, now we can solve for n. So to solve for negative n specifically, we'll say negative n is the exponent, and we're going to use log to solve for this exponent. So we'll say log, and the base we have is this number, so 1 plus 0.135 over 12, and then the answer that it was equal to was this. But we will not put this like that. We will use the ans button. Okay, so negative n equals, and let's go ahead and do that. And when you do that, you get negative n is equal to 23.8055 0.7967, okay? And you can just make it positive by multiplying both hand sides by -1, okay? So that just becomes the positive of whatever it was. Okay, so this is what we get. Now remember, what we were trying to find is how long from here it will take him to pay off this loan. So they want to know the answer in months, okay? They said how many months earlier. So in months, if we're going to consider this, it's 23.79, right? Meaning this part is not a full month. So we have 23 months and then this. If you just say it takes him 23 months, that won't be true because of the 0.7967, okay? If that is not accounted for, he's still going to owe. So we need to find out how long it will take him to complete this loan. So we can say it roughly takes him 24 months. Okay, now let's focus on the question. The question is, how many months earlier will Tsepo pay the loan? Okay, will he repay the loan? How many months earlier? If you know that it's going to take him 24 months from the 1st of March 2024, then if you count exactly 24 months, that is 2 years. So this will be 1st of March 2025, 1st of March 2026. So how many months earlier does he finish paying off this loan? He was supposed to finish on the 1st, 2027. So he finishes this loan in 12 months earlier. Okay, not in 12 months, but 12 months earlier. And so we can conclude that. So in conclusion, Tsepo will repay the loan 12 months earlier. And that is our answer. Question 8.1.1, we have to derive this. Now, do you see what is inside here doesn't really need to be prepared to be derived. We don't have any x in the denominator or any surds, so we can straight away start deriving. So this is equal to, remember it's coefficient times exponent, so that's 3x. And what happens to this x is it has an exponent of 1, but you subtract 1 from the exponent, leaving you with a 0. Anything to the power of 0 is 1, and 3 times 1 just stays 3. Same thing happens here. So we have negative 10x, and of course we have an exponent of 1 left, but we don't have to rewrite it. So this is our answer. Question 8.1.2 says we have to find g prime of x if we are given that g of x is equal to this. So do you see here with this one, you have x in the denominator, you have a surd. Clearly there are things that we need to fix here. So we'll say g of x is equal to, and to sort this out, to make sure that this is not in the denominator, we'll bring it to the numerator. So the 2 stays there because there's nothing wrong with it. And x comes to the numerator, but the exponent will become negative because of this. And then we have minus, and we can rewrite this as x. And instead of leaving this as a surd, we will take the inside exponent and we'll put it over the outside exponent. So that's going to be 7 over 3. And now we are ready to derive. So g prime of x is equal to coefficient times exponent is negative 4x, exponent minus 1, negative 3. Again, coefficient times exponent, negative 7 over 3x, exponent minus 1. So you see that's 7 over 3. If you minus by 1, you can just say it's minus 3 over 3. Or use a calculator. Okay, that's fine. So that is 4 over 3. And this is our answer. Question 8.2 says, determine the equation of the tangent to f of x. As we can see, f of x is a cubic function, and we're trying to find the equation of the tangent to this function at x equals 2. Okay, so here is a representation of what's going on. You see, this is a cubic function that sort of looks like an n, because you can see that the value of a is greater than 0. So it looks like an n, just more curved. And so what is going on is that you have this, and then you have a tangent at x equals 2. So wherever that is, you can just put it anywhere for now. Let's say it was here, okay? So let's say it looked like that. And so that is x is equal to 2. How do we find the equation of the tangent? Because that's the main goal. Find the equation of that tangent. Well, a tangent is a straight line. And so the equation of a straight line is y equals mx plus c. But the thing is, we need m, and then we need another point. So how do we find the gradient of this function, m? We'll find that gradient using the cubic function. So what we know about this point is that the gradient of the tangent and the gradient of the cubic function at this particular point are exactly the same. So that's what we're going to do. We're going to use that theory to find this. So to find the gradient of the cubic function, you would derive it. So f prime of x is equal to, and this will be 3x squared minus 8x plus 2. Okay, now we're specifically saying it's the gradient of the cubic function at this point where x is equal to 2. So to find that gradient, we have to substitute 2 into the gradient formula. So that is 2 is equal to, and when we substitute 2, we'll find out exactly what that is. And we get this gradient is negative 2. So it means that the gradient of our tangent that we're looking for is negative 2. Great. Okay. So we were able to find the gradient of the tangent. And now what do we need? We have gradient. We need C. In order to find C, you just need 1 point on this graph. Okay. Specifically on the tangent. Now you see that the tangent has a point here, but we only know that this point's x value is 2. How would we find the y value? We find the y value because it is also on the graph of f. So let's go ahead and substitute that point 2 into the original equation, and we would find out what the y value is. And we see that the y value when x is equal to 2 is negative 1. So we have a point, 2 and negative 1. Okay, so let's go ahead and use that. So we can just go ahead and use y equals mx plus c for this. We already have m as negative 2, so negative 2x plus c. And then we're substituting. So negative 1 is equal to negative 2 times 2 plus c. And therefore, c would be equal to, you can just multiply here. That gives you negative 4. When you take it over, it becomes positive 4. So that's 4 minus 1, which is 3. And so this means that the equation of your tangent is y equals negative 2x plus 3. And that is our answer. 8.3, given f of x is equal to negative 6x squared. 8.3.1 says determine f prime of x from first principles. Okay, so we can first focus on finding f of x plus h. So we can just substitute it. So wherever you see x, replace it with x plus h. So this is negative 6, and in place of x, we say x plus h all squared is equal to, and then this just simplifies to, we have negative 6 here, and when we distribute that, that's going to be x squared plus 2xh plus h squared. Okay, and then distribute. So negative 6x squared minus 12xh minus 6h squared. Okay, and now we can put down our formula. So f prime of x is equal to, so now this is equal to, and we're going to just substitute. So the limit as h approaches 0, and then we take all of that and we substitute it in place of f of x plus h. And then we are subtracting by f of x, which is negative 6x squared. But you see, you'll say minus negative 6x squared. And so that ends up becoming a plus. So we can say plus 6x squared all over h. Okay, so immediately whatever you were subtracting by is what will cancel. So these two cancel, and we can just rewrite what we're left with. So this is the limit as h approaches 0, and we have negative 12xh minus 6h squared all over h. And now we can finally take out a common factor. And remember, the whole goal is so that we can substitute 0. But the thing is, if you substitute 0 right now, your denominator will be 0. So we want to avoid that. So the limit as h approaches 0, and then we'll take h out as a common factor. In the first term, what will be left? That will be negative 12x. And in the second term, you'll be left with negative 6h. Okay, and this goes all over h. Then these cancel because they divide and give you 1. And now you can substitute. So we're saying f prime of x is finally equal to, and you're saying negative x and then minus 6 in place of h, we put 0. And therefore, this means that f prime of x is therefore equal to negative 12x. And that is our answer. Question 8.3.2 says, write down how you will restrict the domain of f such that the inverse of f is a function. Okay, so remember that f is a parabola. It is negative x squared. So it looks something like this. For you to restrict it so that its inverse is a function, you'd have to understand what the inverse would look like. So this function looks like this. Its inverse, because it is sloping downwards, looking at it from the y-axis. You see that it is facing more towards the negative part of the y-axis. What the inverse will end up looking like would be something like this. So here is your graph. The inverse is going to do whatever your graph is doing, but it's going to do that on the other axis. So if it's facing downwards towards the negative part of the y-axis, the inverse is going to face towards the negative part of the x-axis. So it's going to do that. It's going to look something like this, and the graph will look like that. Now, you see how that is a problem now? This is no longer a function because it will not pass the vertical line test. It's not a function. Do you see how it cuts the graph at two places? It has two different y values for one particular x value. That is not a function. Okay, so we can make it a function by cutting off a wing, okay, and that is really called restricting the domain. So you can restrict the domain by cutting off one wing. And you have to do that from the original. So you have to choose which one you want to stay. The two wings that you have is this part. And what that part says is this is where x is, as you can see, it starts from 0, is less than or equal to 0. Or you could choose to cut off this wing, which is where x is greater than or equal to 0. So any of these would work. If you restrict it using this or this, it's perfectly fine. And then that will have an effect on the inverse. So with this one, the part that will stay in the inverse would be, because it's positive in the x-axis, negative in the y-axis, the part that will stay will be positive in the y-axis and negative in the x-axis. So it'll be this wing. And then, of course, the other one, this one would stay because they're both negative in the x-axis and negative in the y-axis. So that would stay. Okay, so you can use this or this, and that will be perfectly fine. So you can give them any of these answers, and that will be fine. Okay, moving on to the next question. Question 8.3.3 says determine the equation of the inverse for where the y values of the inverse are less than or equal to 0. So this is where y on the inverse is less than or equal to 0. Write your answer in the form of y equals. Okay, so the main thing they want you to find is the equation of the inverse. So let's take our original equation. We can just say y equals, remember it was negative 6x squared. So to find the inverse, step 1, swap x and y. So this now becomes x equals negative 6y squared. And then make y the subject. That's step 2. So to make y the subject here, you see we have y squared. So negative 6 needs to leave. So you can divide both hand sides by negative 6. And now we're going to have, and I'll just rewrite it here. So y squared equals x over negative 6, but you can rewrite it like this. You see there's an invisible 1 in front of the x. So it's actually 1 over 6 and they're negative, okay? And then you can say x. And now to get rid of the squared, we would square root both hand sides, but you have to keep in mind that this is an equation. So when you square root both hand sides, you need to consider the positive and negative solution. And this is where we need to decide. Do you see that they say the y values need to be negative? They need to be less than or equal to 0. So we're simply going to say y is equal to, and we won't take the positive solutions, we'll take the negative ones. That will be negative square root of negative 1 over 6x. Okay, and that will be our answer. And you may be looking at this and think, how would we ever get answers? Because this is negative. Well, you will, as long as x is negative, because you'll have a negative times a negative, which is a positive, and so you will not end up with non-real values. Okay, so that is our answer for this question. Question 9, and we have A 1.9 and B are turning points of the graph of f. So that's a turning point and that's a turning point. Then they tell us that C, which is 0 and 7, is the y-intercept. And the first question is to find out for which values of x is f decreasing. Okay, so let's look at f. You see the graph of f, they told us about the turning points. They said this is a turning point and that is a turning point. So we can monitor what the graph is doing throughout. When you're reading graphs, you read them from left to right. When you look at this part, what is it doing, moving from left to right? It is increasing. We're moving upwards, okay? So it increases and then it does something at the turning point. When we get to the turning point or the stationary points, it stands still. This is where the gradient is zero, neither increasing nor decreasing. Then over here it starts to decrease and then again increase. Okay, so we can see that where it's decreasing is here, and the critical values we will have to mark would be the x values of our turning point. This is 1 and 9, so this is 1, and then this is 5 over 2. So you can see this is decreasing all through from 1 to 5 over 2. So we can tell them this is where x is greater than 1 but less than 5 over 2. Remember, it can't be equal to it because at the turning point it's not decreasing, then it is stationary. Okay, so you can write it like that. You can also write it as intervals. So this would be x is an element of round bracket because it's not included from 1 to 5 over 2, and that would be our answer. The next question is to write down the x-intercepts of the derivative of f. Now notice that they did not give us the equation of f, but we have to find the x-intercepts of the derivative. Okay, so this has to do with a little bit of understanding with graphs. We have a cubic function, and as you can see, it's a cubic function that sort of looks like an n, just more curved. So this is a cubic function where the value of a in ax cubed is greater than 0. Okay, so when you derive this function, it will form a parabola, and the parabola is also going to be concave up since it came from a cubic function where the a value was greater than 0. And what will happen here is the x-intercepts are going to have the same x values as that of your turning points. So the answer to this, the x-intercepts of the derivative of f, would be 1 and 5 over 2. So that's going to be 1 and 0 and 5 over 2 and 0 since they are x-intercepts. And that is our answer. Question 9.3 says, for which values of x will f be concave up? Okay, so we have our cubic function, right? And looking at the cubic function, there are two types of concavity that we have. You will notice that there is a part of the cubic function that is concave down. It's curved down like a parabola. And there's a part that is concave up over there. Now we need to find out for which values it's going to be concave up. And we can clearly see that is this part over here. But now we have to find out where does that start. How can we point out where this starts? Well, where it changes concavity is at the point of inflection. Okay, so if we find out exactly what the point of inflection is, we will be able to find out where it changes concavity. Now you'll notice I brought the parabola back, and there's a reason for this. You see, to find out where the point of inflection is, look at the parabola. Do you see that the parabola, if these are the x values, for you to find the turning point, or at least the x value of the turning point of this parabola, you can use the x values that you have here. So it would be right in the middle of these two x values. So if you said find the midpoint of these two x values, meaning x1 plus x2 over 2, you would find that x value of your turning point. Now that x value of the turning point also happens to be the x value of your point of inflection. So that's how we're going to find that. So we're going to find that x value of the point of inflection by saying x is going to be equal to 1 plus 5 over 2 divided by 2, which is equal to 7 over 4. So 7 over 4. And now we can see where it will be concave up. We know it's concave up here, and we know this is 7 over 4. So it's concave up for all the values of x that are greater than 7 over 4 because it's concave up all through there. So our final answer is therefore x is greater than 7 over 4. Of course, if you want to write these as intervals, it's going to be x is an element of, and it starts at 7 over 4. So you know that it's moving towards parts that are greater. So starts at 7 over 4 and then ends at positive infinity, moves towards infinity. And there we go. You can write it like that or like that. Question 9.4 says, determine the value of k for which y equals f of x plus k will have 3 positive x-intercepts. Okay, so we need to use the graph for this. We don't have an equation, and they're specifically speaking about positive. You can only control that from the graph. Okay, so here is our graph, and focusing on getting 3 positive x-intercepts, let's just draw an outline of the graph so we can better control it. Okay, so here is our graph, and let's just see. Right now, looking at the graph, how many x-intercepts do we have? We have 1. It's this one over here. Okay, we have 1 x-intercept there. But now we needed to have 3 positive x-intercepts. So in order to get more x-intercepts, you have to shift this graph down, not up. If you move it up, it does not help. It's just going to keep having 1 x-intercept. So we need to move it down. But how far down? Okay, you can control these because you're specifically trying to get 3 positive x-intercepts, or 3 intercepts really. If you start moving it down and focus on this part, the local minimum turning point over here, focus on that. If you move that until it hits the x-axis and sits on the x-axis, look at how many intercepts you have now. You have 1, 2. So we want 3, right? If you move it down any further than this, then you start having 3 x-intercepts. There we go. And they're all going to be positive. And we know they will be positive because this was 7 over here before. When you shift it down so that it is right here at the origin, okay, so that the y-intercept is at the origin, you see that that is only moving it 7 units down. But if you shift this until this turning point sits on the x-axis, then it means that now you have actually shifted it down by 8 units. So it's down by 8 units. And so this, the y-intercept, is now -1. So let's leave this graph here because this is going to be a very important point. And then we'll create another graph. Okay, so this is a duplicate. And if we move this down so that it is here, do you see now it has 3 positive x-intercepts? And that's what we want. We wanted to have 3 positive x-intercepts. So if you keep moving it lower than this, it still has 3 positive x-intercepts if it's here and here until the local maximum sits on the x-axis. Then it has 2 x-intercepts, okay? Just 1 there and 1 there. So if it is anywhere in between here, then it is perfectly fine, and then it has 3 x-intercepts. So let's find out how we would find this. Remember that they say f of x plus k. So plus, but we can see that we need to move this graph down. So k needs to be negative. We'll keep that in mind. K should be negative. We saw that when we moved this graph until it got to this point where the local minimum was sitting on the x-axis, then we were able to get 2 x-intercepts. And then if we move it anything further than this, we get 3. So how far down did we move it here? Do you see that this was exactly at 8? You moved it so that this sits at 0 on the y-axis. So you moved it 8 units down. So let's keep that in mind. We need to move it anything more than 8 units down. But then we can't just keep moving it more than 8 units down. We need to stop at some point. So move it more than 8 units down, but no more than how many units down? How did we get to this point over here? Because after this, it will no longer have 3 x-intercepts. And of course, at this point, it has 2 x-intercepts. So no more than how many units down? Well, you can see that easily from this side. Okay, so you're going to have to look at the local maximum. It used to be at 9, and then it moved down so that this y value is now at 0. So we must have moved it 9 units down. Okay, so it should go down more than 8 units, but no more than 9 units. Okay, so now that we have that down, we can actually interpret this properly. We know that we're referring to k, but let's also take into account that k is going to be moving down, which is a negative shift. So we can't just leave k positive. So look at how we can look at this. We can keep in mind that k is going to be negative, okay, because it needs to move down. And we can tell them we want this shift to be anything more than 8, so greater than 8, but no more than 9, so less than 9. And then when we look at this, we're like, okay, we're close, but we're not done. Because the k is negative, we need to solve for k, not negative k. So let's solve for that by multiplying both hand sides by -1. And when we do that, the k is now positive. But remember what happens when you multiply by a negative. Sure, this becomes -8 and that becomes -9, but it also causes your signs to change direction. So that now looks like that and that looks like that. And I know it looks awkward because it's not being put in the correct order. You know that on the number line, -9 is more to the left than -8. So you just have to rewrite it properly. So this means that k simply must be greater than -9, but less than -8. Because that's what it's saying. The mouth of the inequality, where the bigger value is facing the k, meaning k is greater than -9, but k is less than -8. And you can see how that makes sense on the number line. Okay, so it's values that are bigger than -9 but less than -8. And that is our answer. Question 10 says, a cyclist rode from town P and stopped at town T. The speed at which the cyclist rode is represented by the equation s prime of t. So this is just the speed itself. Note, speed is the rate of change in distance with respect to time, okay? And 10.1 says, calculate the maximum speed that the cyclist reached on this ride. Okay, so in this case, you just have this cyclist riding, okay? So, and they gave us the speed only. So we're looking at it like this. This is your x and your y axis. Do you see that the speed is in the form of a parabola? And you also notice that the y-intercept, the plus c part of this, is 0. Okay, there's nothing there. So your parabola is going to look something like this. It's going to pass the origin and it's going to look like that because of that y-intercept is at the origin. So maybe something like this. Okay, so I just made some adjustments to it. So this is s prime of t. And we have to find the maximum speed which the cyclist reached. So now do you see that the maximum is over here? Okay, it is a parabola and you have to find the highest, okay, point on this parabola, which is the turning point. So we'll take s prime of t, which is just the equation of the parabola, so long the speed, and then we would need to derive. So we'll say s double prime of t is equal to, and when we multiply coefficient times exponent, we get -6t and then plus 18. Remember, when you're deriving, you're trying to find the gradient. Okay, so this is just the general gradient, but we specifically want the gradient at this point, and we know the gradient is equal to 0 here. So we'll say s prime of t is finally equal to 0, so -6t plus 18. Then we can just take this over. So it's +6t is equal to 18. And to solve for t, you can divide both hand sides by 6, and therefore t is finally equal to 3. Okay, so you see that we found t, and t is really just telling you the time at which this happens. So these parts, the y-axis, the points that you will get here, like for example, this point is going to give you the information about the speed at this particular time. And this time is in hours because this is kilometers per hour. So we'll take that and substitute it in this equation. So 3 and substitute. And we get a speed of 27. So S of 3 is equal to 27. And remember that the speed is in kilometers per hour. So that is going to be 27 kilometers per hour. Okay, moving on to the next question. Question 10.2 says, calculate the distance between town P and town T. Okay, let's look up and just see the information that we have, what we can use to find this. Now, from this, do you see the note they left? Saying, note, speed is the rate of change in distance with respect to time. And they specifically left this as s prime of t, meaning you must have had an s of t. If this represents the speed, then s of t would represent the distance with respect to time. So when you take the distance and you divide it by the time, when you put it over the time, you are going to end up with the speed. So our goal right now would be to find s of t. If s prime of t looks like this, let's try to see what s of t is. So we're looking for s of t. Think about how you must have derived your function to get this. If your function, right, s of t was like this, you would have had a value that you would multiply. You can call it anything. I wouldn't want to call it x. So let's say we had some number here, right? And then you would have had t. But because this derivative is a parabola, it means that the original was a cubic function. So it would have been raised to the power of 3. You would have said this multiplied by 3 to get this number over here. So this would have been negative t cubed. And then you have 18t here, so we can also find what that would have been. So you would have had plus something, again, t raised to the power of 2. So what multiplied by 2 gives you positive 18? That would be positive 9. So this must have been positive 9t squared. And you see now that we don't have any constant, meaning you definitely didn't have anything that was like, for example, plus 3t. Because if you did, then there would have been a 3 here. And then we would know that, okay, this was derived to get 3 because the derivative of 3t would be t. But the only one we wouldn't be sure about is the constant. If you had a constant here like 1, if you derive a constant, you get 0. So do you see that we wouldn't really know if there was a constant here or not? Okay, so let's just look at the information that we have. So right now we can just say plus c, right? And just say this is possibly something that used to be there. Let's think about it logically. If this is the distance with respect to time, right? There's certain points that we will be sure about. This cyclist is traveling from town P to town T. From town P, the cyclist would not have traveled any distance. So when no time had passed, so if T is 0, the distance would be exactly 0 as well. So that's something we know. We actually know a point here. And this is a special point. 0 and 0 is at the origin. This would mean that both your x and your y-intercept are 0. If that happens, just like it did here with the parabola, do you see how we had negative 3t squared plus 18 and then nothing here? And so because of that, this graph passes the origin. It means that this graph will do the same thing because it means now that your y-intercept is actually 0. So we know now for sure that s of t actually looks like this. S of t is equal to negative t cubed plus 9t squared. Okay, now to find the distance between P and T, what else do we know about these points? Apart from this, the only other formula we have is the speed, right? So with the speed, how can we actually point out these 2 points? With the speed, you can think about it like this. You see at P, because this cyclist just started riding, at t equals 0, the speed would be exactly 0. Okay, so the speed is 0 here, but the speed is also 0 somewhere else as well. Because the cyclist starts riding, and the speed increases. And then it increases to the point that it reaches the highest of 27 kilometers per hour. And then it decreases. And then they stop. The speed becomes 0 again. And that will be over here. The speed is 0 here because the cyclist is not moving anymore. So that's actually something we know. We know that when the speed is 0, this marks the starting and the ending point of the cyclist's journey. So how about we make speed equal to 0 in this equation? We're going to say 0 is equal to, and we put down the formula for speed and find out where was the speed 0, because we just want to find out what t is. We know what p is, but we need t. So this is going to be equal to, we might as well divide both hand sides by negative 3. And now we'll have 0 equals, and this is now positive t squared. And 18t divided by negative 3 would be negative 6t. And so therefore, you can take t out as a common factor, and then you would have t minus 6 is equal to 0. And therefore, this means that t is equal to 0 or t is equal to positive 6. And this makes perfect sense. So the places where the speed is exactly at 0 is where the time is 0 hours and where the time is 6 hours. Because at 0 hours, you just started riding. At 6 hours, this cyclist stops. So we can just find out exactly what the distance is. This is the distance formula. Find out what the distance is when the time is 6 hours. So after 6 hours, what was the distance? So we'll substitute in place of t, substitute 6. So this is s of 6 is equal to, and then we substitute And then we get a distance of 108. And remember, the speed was in kilometers per hour, so the distance is in kilometers. Okay, and that will be our answer. It is the distance from P to T is 108 kilometers. Okay, we have question 11. And question 11 says, a certain number of learners are sitting for examinations in mathematics, tourism, and geography. All these learners sit for at least one of these exams. And then they also tell us the total number of learners who sit for mathematics is 22, total of tourism is 16, total of geography is 18. And then they start telling us about the intersections. And so you can see from here where they say 5 learners sit for mathematics and tourism but not geography, then mathematics and geography but not tourism, and tourism and geography but not mathematics. You can see that all of them intersect. So we will have a Venn diagram and we'll have 3 circles that intersect. Okay, so we have 3 intersecting circles: mathematics, geography, and tourism. So when working with the Venn diagrams, you need to start from the intersections. So we'll start here where they say 5 learners sit for mathematics and tourism, but not geography. If they're saying mathematics and tourism, this would be the intersection of maths and tourism. But now they say not geography. So you would exclude everything belonging to geography in that intersection. So it will just be this part. And how many learners are there? It's 5 learners. Okay, so we have 5 learners over here. And then they tell us that 4 learners sit for mathematics and geography, but not tourism. So mathematics and geography, that's that intersection, excluding tourism. So it's just this part over here. And that is 4 learners. Then 3 learners sit for tourism and geography, but not mathematics. So tourism and geography, but not maths. So that would be 3 learners over here. Okay. What other info do they give us? Here they say 6 learners sit for tourism only tourism. What they mean by that is it's not the entire circle. It's not everybody who sits for tourism, regardless of them sitting for maths and geography. This is people who sit for only tourism, so they will go here. Okay, so do we have an intersection or do we have a means of finding that intersection? Okay, it seems like we do, because they say the total number of learners sitting for tourism is 16. Now, this is what this means. The total number of learners, meaning regardless of whether they sit for geography and maths, they sat for tourism. Okay, so they sat for maths and tourism. They sat for tourism and geography. Okay, but they all sat for tourism. So if this adds up to 16, then we can actually find out what this middle is. Because this is a total of 16, meaning everything here will add up to 16. So to find this, you'll say 16 minus all of these numbers. So 16 minus 6 is 10, minus 5 is 5, minus 3 is 2. So the middle is 2. So 2 learners sat for all 3 subjects. Okay, so we're done with that. Then the total number of learners who sat for maths is 22. So that again is like this. The entire circle of maths is 22. So 22 minus 2 already gives you 20, minus 5 gives you 15, and minus 4 gives you 11. So 11 is here. So that means 11 learners sat for maths only. Okay. And then we're done with that. Then lastly, we'll deal with geography. So the total number of learners sitting for geography is 18. Total number. So the entire circle of geography adds up to 18. So that's 18 minus 3, which is already 15. Then minus 4, which is 11, and minus 2, which is 9. Okay, so that's 9 over here. And okay, our Venn diagram looks good. Let's just see anything that we missed. Do you see that they say all these learners sit for at least one of these examinations? So what this means is everybody in this study sat for an exam, meaning you don't have anybody on the outside. And that would mean that this is our Venn diagram and we're done. We don't have anybody on the outside who is not included in any of these circles. Okay, so that is 11.1, and moving on to the next question. Question 11.2 says, calculate the probability that a learner chosen at random will sit for examination in at least 2 subjects. Okay, so let's break down what at least means. At least just really means at lowest, meaning the minimum amount of subjects that these learners sat for would be 2 subjects. Okay, so we're looking for learners who sat for 2 subjects. Let's see, at least 2 subjects. So looking at this, let's just look at each of these numbers and just see how many subjects they sat for. These 11 learners, how many subjects did they sit for? Do you see that they are only in maths? Okay, they're not in the mixture of maths and tourism or anything like that. So these learners sat for 1 subject. If you look at these learners here, they sat for maths and tourism, excluding geography. So they sat for 2 subjects. The minimum amount of subjects we are picking would be 2, meaning you're allowed to take 2 subjects or anything more than that. Okay, minimum amount, at least 2 subjects. So that would be 5 that we'll take. And then if you look at 6 is for learners who sat for tourism only. That is 1 subject, so we don't take that. And then 4 is for maths and geography. So that's 2 subjects, we'll take that. And 3 is for geography and tourism. So we're also going to take that because that's 2 subjects. And the middle, these 2 learners, they sat for maths, tourism, and geography. That's 3 subjects. So that would be at least 2, at lowest 2 subjects. Okay, so we're going to have to add up 5, 2, 4, and 3. Okay, if you add 5, 2, 4, and 3, it gives you 14. So we have 14 over and then the total number. So if this is 14, that already gives you 20. And then this is 20 on its own. So it's 40 learners in total. So that's 14 over 40, which of course will simplify. Okay, so at least 2 subjects, and then that simplifies. So 14 divided by 2 is 7, and divided by 2 is 20. So the answer is 7 over 20, left simplified. You can leave it as a decimal, that's perfectly fine as well. Okay, moving on to the next question. Question 11.3 says, determine if the events sitting for examinations in mathematics and sitting for examinations in tourism are independent. And then support your answer with the necessary calculations. Okay, so we're going to have to use the formula for independent events. If 2 events are said to be independent, then this is what is going to happen. So this means that the probability of mathematics and tourism would be equal to the probability of mathematics multiplied by the probability of tourism. Okay, that would be the case for independent events. So if they are equal, then it really means they are independent. Okay, so let's find the probability of mathematics and tourism. See that first. So this would be equal to, if you look up in your Venn diagram, tourism and mathematics, the intersection of them would be here, right? They didn't say tourism and mathematics and not geography. So this is this entire intersection, which is 7. So 7 over 40, that's the total we have. So we say 7 over 40, and we'll keep that. And now let's find out what the probability of maths multiplied by probability of tourism would be. So this is going to be, let's check. Probability of maths, we already knew that because they said here 22 learners sit for maths. So that would be 22. This is the entire circle of maths, okay? That is 22 over 40. 22 over 40 multiplied by probability of tourism. And we know that tourism was 16 in total. So that's going to be multiplied by 16 over 40. And we just have to check if it actually does give you the same answer. So here you can actually find this as a decimal. It's better like that so that you can better understand what that number is. Okay, so 7 over 40 is 0.175. And then let's see what we get here. If we say 22 over 40 multiplied by 16 over 40, what do we get? We get 0.22. You see how those are not the same numbers? So that would mean they are not equal. So we can actually tell them these are not equal, and so therefore these events are not independent. Okay, so we can put a line through it here. It's not equal, therefore the events mathematics and tourism are not independent. And that is our answer. Question 12 says a company generates a 4-character code using the 26 letters of the alphabet and 10 digits from 0 to 9. Okay, the code is in the form of letter, digit, letter, digit. And 12.1 says determine how many different codes can be formed if the letters and digits may be repeated. Okay, so this one, first question is quite simple. We know the way they go. It's going to be a letter, digit, letter, and a digit. And we know that the first character will be a letter, and you're allowed to use all the letters. There's no restriction. So there are 26 letters in the alphabet, so 26 choices that we'll have. And then the second is a digit. You're allowed to use numbers from 0 to 9, which is 10 numbers, so you have 10 whole choices. But we're still allowed to repeat. Repetition is allowed. So again, with the letter, we'll have 26 choices, and with the digits, 10 choices again. Okay, so we can go ahead and find out what that is. It's really just 26 squared times 10 squared. Okay, so let's find out what that is, and that would be the number of codes that can be formed. So that is 67,600 codes that can be formed. And that is the answer to that question. Question 12.2 says, determine how many different codes can be formed if the letters D, F, I, Q, U, and V may not be used. The code may not start with W or Z. Letters or digits may not be repeated, and the code ends with an odd digit. So here already we have a number of restrictions. Okay, let's just look at what the code is going to now look like. Okay, so it's still a 4-character code. So with these types of questions, it's best to start with those strict restrictions where, for example, you're only allowed to use a specific type of digits or numbers in a specific position. Like here, where they say that the code may not start with W or Z. Okay, so because it's a letter restriction, we can actually just speak about that. Remember that we have letters first, then digits, and then letters, and then digits. Okay, so now that we have this down, let's look at this. They first tell us that the letters, all of these cannot be used. So that is, let's just make sure we know how many. 1, 2, 3, 4, 5, 6 letters can't be used. We know that there are 26 letters in the alphabet. You're not allowed to use these 6. So you're down to 20 choices that you can use. But the first letter, and we can start with the letters so we can understand what's going on here. The first character, right, first letter must not start with W or Z. So you were already allowed to use 20, but now you can't use W or Z. So you can only use 18 letters here, okay? 18 choices that you're allowed to use. And then let's look at the second letter. Remember that repetition is not allowed. They say you may not repeat. So how many can we use here? The thing about this is if you were allowed to repeat, you would be allowed to use 20 letters, but you can't repeat. So now you're down to how many? 19, because a letter would have been used here. So to ensure that you don't repeat, we'll say 19. And now we can look at the digits. So this digit, is there any restriction? Okay, there's a restriction on the last one. They say the code ends with an odd digit. So you're only allowed to use odd numbers. Remember, it's numbers from 0 to 9, as they said. Odd numbers would be 1, 3, 5, 7, and 9, not 0. 0 is not an odd number, it's an even number because it can be divided by 2 and it will still give you a whole number. So you're allowed to use these 5 numbers, okay? So because it must be an odd number that it ends with, you're restricted to 5 numbers here. Okay, and then let's look at this. This one didn't have any restrictions, meaning you would have been able to use 10 numbers here, but repetition is not allowed, so that leaves you down to 9 numbers. So we just have to multiply these, and that will be the total codes that we can make up. And so the answer is 15,390 codes. That's the amount of codes we can create with those restrictions. Okay, moving on to the next question. Question 12.3 says, the company wishes to increase the number of 4-character codes formed in question 12.2 by allowing letters D, F, I, Q, U. Was that the same letters? Okay, yeah, it's the same letters that they're allowing now to be used. Calculate the percentage increase in the number of different codes that can now be formed. Okay, so this one is quite simple, really, because it's really the same case. They're not changing anything except for these letters that you're now allowed to use. Before, we couldn't use these 6 letters. Now we can. So it means that all the letters will increase by 6. That's really just what's going to happen. So this increases by 6, and 18 plus 6 is 24. Then 19 plus 6 would be 25. Okay, so that would be the new amount of codes we can make. But the main goal, they ask us to calculate the percentage increase in the number of different codes that can now be formed. So from this one, what is the percentage increase? Okay, let's find out how many codes we can now have. And that is 27,000 codes. So we can now have 27,000 codes. So to calculate the percentage increase works like this. You just want to calculate the difference, really. So you're going to say 27,000, the bigger one, minus this one. So that's the old one, 15,390. So 15,390. And then you're going to put it over the old. And the reason why is because you're trying to track how much it increased by. So it increased from the old to the new. So over 15,390. And then you want to ensure that this is a percentage. It's going to be a decimal like this, or fraction. So you multiply it by 100 to get it to become a percentage. And this will be the percentage increase. And that gives us 75.44%, rounded off to 2 decimal places because that rounds up. Okay, and that is our answer. So that's the end of this paper. I hope you guys enjoyed it, and I will see you guys in the next one.